morning, everyone. Thank you all for joining us so early, for waking up so early. So glad you've all made it here. I'm František, I'm from the Peki team, and I'm joined by Miroslav Bartkerty from the testing farm team, and I'll let Miro sit here for a while and tell you what we have prepared for you. If you are here for a controversy, sorry, don't expect that much. So we would like to show you what is actually not changing, what's preserved, what is changing, and why we are doing all of this. Then what you can try and play with right now, and what are the plans for the future. And Miro will then show you some interesting things about testing farm. So just a quick context, what we are speaking about. So I'll try to use term Fedora dist-git CI as a generic term for any CI solution running on dist-git, meaning Fedora dist-git. Pull requests, then there is a d-Fedora CI, that's the one solution, one service that provides this dist-git CI, and also it provides CI for body updates. There is also Fedora Zul CI, which is a tenant, Zul tenant running in an opt-in way, so this needs to be enabled, and it can run either TMT or Ansible-based tests. So these are the things that are currently available. So let's take a look at what's staying. So there is and there will be a CI running on pull requests by default for all the packages. There will be a Koji Scratch build being run for these pull requests, and then there will be a test run using testing farm, and we are using TMT as a test definition, let's say, behind these. So we are actually like just swapping the mechanism that's handling all of this, but no worries. Basically, what you rely on should stay the same. And now what will actually change? But before that, I'll try to cover what is a packet. Everyone knows zero packet. Who knows packet here? Okay, someone is not sure, so let's cover that. So packet's goal, if you don't know, is to bring upstream and downstream, meaning Fedora, closer together. So that's our goal, and we used to have two solutions for this. One is to provide upstream CI, so for GitHub and GitLab, provide an opt-in way how to run Copper builds, Koji builds, tests using testing farm, OpenScan hub checks. We have also a prototype of image builder integration. So a couple of things that you can run on your upstream projects. Then there is a Fedora automation. So we are trying to help maintainers to get their upstream release down the Fedora way closer to the user. So you can use like this release syncing, so a code that takes the upstream release and prepares a dist-git PR for you. Then if this PR is merged, a Koji build is triggered, and once there is a successful Koji build, there is a body update. These are all like configurable. You can pick just what you want from these. Now we are trying to provide a Fedora dist-git CI. This is the new thing we are trying to show you now. That will be by default and no configuration, so similar to the Fedora CI mentioned before. So and the functionality I've mentioned, Koji Scratch build on pull requests and the tests being run on top of that. If you are interested about the Fedora automation part, just a small note that there will be a workshop tomorrow, so please join Laura and the rest of the team, or you can also discuss anything during that time. So I'll divide these use cases to two. One is the opt-in way, and one is the default. And that's actually what we are trying to differentiate to not confuse people. We need to do more of this, but basically there will be this default solution running for everyone, and then there will be these opt-in ways. We are happy if people use both, but if not, that's completely fine. It's not like related completely. It's just that same team and like some same team is taking care of this, and also some code is being shared. So actually, why we are doing all of this? Main thing is that we do really think that pull requests are important. One, in general, that we think that that's a nice way how to collaborate and provide feedback. But also specifically with Packit, the pull requests are key part of the whole workflow. With Fedora automation, I've mentioned that. And that's the key part. Since we are automating all the steps, we need to have some way where we are collecting like feedback from the people, from the services. So for us in Packit, the pull requests are really important part of the workflow. So that's why we care about that. And since the situation about like the current services wasn't the ideal, and there's nothing, I mentioned that explicitly there, we have nothing about the services or the people behind this. They spend a lot of time on this, so they deserve a credit, but usually they have other priorities, so we understand that that there are reasons why this is not taken care properly. So that's what we actually would like to change and help, because we have most of the code ready. We have integration with testing farm. We have a lot of API ready for the Azure integration, for GitHub integration, or the Git forges in general. So technically it's feasible. So let's help if the situation is not nice. So that's our motivation, and we can maybe like provide similar experience we already have for upstream. So what is changing actually, what we're trying to improve is that we have a dedicated team that is taking care of Packit and Fedora Git CI. So we believe that that we can provide some like not only to maintain that, but also like improve, because there were a lot of like old issues that weren't fixed. So we would like to be proactive, and I hope we've learned something during the time with trying to onboard people to Packit, that we really need to listen to people. So I hope we can leverage from that. Also, since we count with Forgeo support, the other two solutions don't need to care about that, and we are currently like going through the Forgeo support, nearly done on that front. Small note: underlying we use this Opal library. So if you have any other tool that needs a Git forge dependent code, so please use it. You will get Forgeo support for free then, and you don't need to care about the migration later on. Also, we have a nice, I would say, or robust testing farm integration, which is both from technical point of view, that we have various like reruns, or we are babysitting, so-called babysitting the results. So we are proactively checking that really we receive the results, but also on the personal level. We are part of the same group. We are really close, so we collaborate like for a couple of years. So I think that's also a benefit. Okay, so let's take a look what we have now. Here's the plan we've proposed as part of Fedora change. So we phased this. So there were like three implementation phases. One is to provide like scratch builds in opt-in way, then the installability check and the custom this git test. So these are done, and now the final part is like becoming the default solution. Okay, so what opt-in means? We have a configuration file. You can send a pull request and put your project URL there. If you do this, you are enabled and you can start playing with that. We really want to see your feedback to when we switch to the default, to know that everything is as you are expecting and your use case is like supported. There is a packit.dev/fedora-ci page that covers like the documentation, what's being run, how to do the things. What's currently run on the Azure pull request is that the Koji scratch build is being run. Then we are taking that scratch builds and running testing farm job as an installability check. Regarding the installability check, there are a lot of feedback about how to do that, how not to do that, which one to take, because there were at least 3 definitions in the around of the installability check. So people had opinions, and we said, let's not mix those two discussions together, because we are trying to like improve the system, and this could easily change the topic to how we are doing an installability check. So we are currently using the same one as before, and we can improve. There is a bunch of interesting points in that issue tracker, so we can improve later on. Also, we have time to better understand these. There are also dist-git tests, so the custom test plans. So if you have a TMT setup in your repository, these plans will be automatically like run for you. And since this is a default solution, there is no package YAML, no configuration like on the package side, but you have plenty of options on TMT side. Yeah, there are a couple of things how to influence other stuff, but later about that. You can also retrigger things. Yes, sometimes it's needed, some flags, etc. You know it. So each step can be rerun, either all tests or those two groups. If you need something else, let us know. We can add those, but currently that's that. And also all the naming and all the functionality, please let us know what you need or what you think about that. Now is the time to change things before we introduce everything. So just to show you that we try to care about like UX, one small thing is that if you have this doesn't happen so much in upstream, that you have like a single commit and multiple pull requests from that single commit. But with this Git, that happens quite. If you are, for example, releasing from same commit to multiple these Git branches. So in that case, we are trying to differentiate the statuses. So because underlying the statuses are tied to commits and not to the pull request, in Persian not anymore, and that's a good thing. So we are differentiating, so you know which result leads to F42, which results to row height. So just a small thing, but let us know also with other things that we might want to take a look. And there is a QR code. That's a generic thing. We are using a lot of things from Packet, and we have this survey going on about like mainly about Packet's dashboard, how to do things, because we are connecting a lot of services, so we are trying to think about how to do this like more cohesively or like show you the right things. So if you care what we are showing, please fill this survey. It's really quick, just that showing what's important for you, which kind of information, so we can prioritize that. We very value that. Okay, so what's ahead of us? I mentioned that, and I'll probably mention that multiple times. We really want to see your feedback. Now is the time. We are like from the implementation point of view, we are mostly done. Now is the time to collect feedback, polish things. We have a GitHub discussion thread for that, but feel free to like chat with us on Matrix or create issues. That's completely fine as well. The second, both are probably same hard. We would like to separate our code base and move this one to Fedora infrastructure. So that's what we are currently focusing on. So part of this is on our side to like clean up, split these things, but also to the deployment part. So it's also less messy for the people, but also that since it's becoming a part of the RPM workflow, we would like to also others to be able to maybe deploy that if things go wrong or something like that. So also to be more closer to other Fedora services, because we think that it's becoming like important part. So let's be closer together. Okay, and when we are introducing things, the crucial part is also getting rid of things that we don't need anymore. So the crucial thing will be to get rid of the other solution. As I mentioned before, in regards with Fedora's UCI, I've discussed with people behind the tenant. They don't have capacity to continue that front, so we would like to maybe document more like how to move away from Fedora Zoo CI, but that would not continue in also in case of Forgeo, and also in case of Fedora CI, we might want to turn off this git test. Regarding the deadlines, as part of the Fedora change, we are thinking about like August to do the switch, but we want to do that once we are really sure and once Fedora is in the Fedora infrastructure, so we don't have this big change as part of like the regular run. Okay, but we would like to announce it around like in a month, so we have like more clearer date that we are really sure that we'll make it. Okay, and also mentioned deprecating of Fedora CI. It makes sense only when we can deprecate it fully, so that's not like a short-term plan, but later on we might want to take a look at like the body run checks, and so like the same thing is being run. Another thing, it's not like in upstream that projects have these separate tests, but usually there are like tests that are shared between all the packages. So what I would like to see is to have like a clear place to like maintain these together. There is a clear way like who is responsible for that, and also a place to collaborate on these, and also like a place to decide like these are the tests that we are running for all the packages. So that's like my focus, what I would like to play with. If anyone wants to be part of the discussion, I would be happy to. So we can maybe design a solution that is not like some random code in package code base that this installability check and RPM inspect is being run, but a clear explicit way, like these are the 2-3 checks that are being run, and when there is a new one, this is what needs to be done. Okay, and small UX thing again, we used to have this old issue to being able via CI FMF file to be able to split the plans. We are thinking if it still makes sense or if this shouldn't be a default. So if you have an opinion on this small thing, let us know on that discussion, and I'll pass my word to Mere.
Thank you. You are quite quick. I usually have like 3 minutes on 6 slides, so that's awesome. And I usually make it. Yeah, okay, so some news about testing farm. Like this year, we started off with some firefighting. Like we already like were maintained our SLA for testing farm, but we found out that there are some really real problems that we need to look at. So we like spend time to add additional monitoring and so on and fix some long-term issues. One of the things, there was a very nasty bug there for I think 2 years that was causing the memory consumption of our worker nodes was very high, and that could cause auto memory issues. But there was also RPM inspect, which is using ABI diff, and there is the ABI diff tool for some very large code bases like IceCat and some others. They WebKit to GTK. Yeah, they are very they put a lot of memory pressure on our workers. So these issues are fixed, and yeah, you should see improved stability like all over the board for testing farm requests. Again, it was like not happening much, but happened that the tests or the runs got stuck in the running state. One thing that we like worked on for the last time or the last few months is image mode testing. This is something that we like. Our vision is to be able to test image mode as easy as package mode now, all over the place. Also in this Fedora CI, this Git that František now presented, but basically from everywhere. Like it should be really easy. Ideally, you should not even need to change the tests. Maybe add some configuration to the Git to be able to optionally execute the test. But I hope that we will be like, this is what is happening in RHEL, that we will run all the tests on the image mode also next to package mode. So we are testing both flavors of the operating system that we love together, right? We will have a dedicated presentation on DevConf. If you are there, please join us for technical details. If you would be trying this now, it's not working. I was not able to fix it before the presentation. We have the images actually generated, but I need to fix some configuration on the provisioner side, so basically it works. I think it will work in a few hours, but yeah, did not make it after the before the presentation, so I'm sorry. But try tomorrow, for example. Yeah, another thing that we'll be presenting at 10:30 now here on this conference are testing farm test environment profiles. What is addressing a long-term issue, basically how we expose to the users how the testing environment is prepared when testing farm basically provisions a Fedora machine. We are maintaining a bunch of Ansible playbooks currently on our side that are really hard to discover, hard to replicate. So we have some reproducer steps that testing farm is using, and this was like some hidden thing there. So we are introducing a more reasonable way how you can replicate that setup and how this will be used and how it will be discoverable from the testing farm results. You will see which profile is being used. So we'll have dedicated profiles for Fedora CI, CentOS CI, Packit, and internally for LCI, Ribos, and all other, and adding new profiles will be very easy. That will also help us to address some long-term issues where there was a clash between the requirements between Packit, for example, and Fedora CI, where we did some setup which was really not working well for the upstream use case or was not needed and was causing, again, this user discomfort. But František mentioned that there will be no Packit YAML in Fedora CI dist-git, so we are, or probably, it's not completely decided, but like now we have an agnostic way or user agnostic way to like specify or modify the requests with our own configuration file in dist-git. We introduced this to basically ease, I would say, the integration with the CI systems in a way that they don't need to introduce certain features, and you can basically change it via this configuration file. One of the things that we have implemented in the last year was like adding secrets. Like everywhere where testing farm is being run, you can now safely basically include a secret into the pipeline. For example, if you would need to push something and so on. This is not so common for Fedora CI dist-git, but definitely will be common for Pager, the Pager IO or 4GO. Once you have a normal project there, where we'll be also running, and it's a really good thing to have in the upstream Packit integration. Of course, like this, it's encrypted, and we spend a lot of time to make it secret. It's like basically if you fork the repository, you will not be able to expose the secrets. We have an RFD page for it on our documentation page. Like we spend literally months like finding out if this is like really secure, so don't be afraid. And yeah, it's tied to a specific repository. If you fork the repository, you will be not able to steal the secrets, and the other common obstacles can be avoided. This also like brings a little bit like maintenance stuff, but like yeah, that's how it is. Like the best thing that we could come up with. Packit has issues like consuming directly secrets from GitHub. GitHub is not allowing that you would have some secrets and it will be shared in Packit. So this was the only solution. The nice thing is that it works anywhere where you use testing farm. So it's like the user agnostic way. Another thing that we'll be enabling in this with this configuration is basically enabling multi-host testing. Currently, that's a separate pipeline. So that's the thing that we have in the plan, and also image mode testing. So when you will like for the time that the image mode testing will be opt-in, you will be able to like enable it or add basically another job that will run against image mode testing here in this configuration file. And the last thing I want to mention, we support now bare metal host on testing farm. This is used, for example, for systemd. They run 40 VMs at once on those beefy Amazon machines and like do their testing. So it's definitely possible to like request now a very beefy hardware, but also to be able to even like properly test your virtualization use cases. So I think that's pretty cool. And we added also for this AI workload some dedicated GPUs that we have access to. So you are able to now get basically an instance with a dedicated GPU and try it out. We are still looking for customers for this, and we need to do some configuration changes to provide more types of the GPUs that are available on AWS. Unfortunately, yeah, it's limited, so you don't have access to these very strong graphic cards. But maybe sometimes somebody else will come and provide us some hardware so we can extend this. Oh, that's all. 1 minute early. No, 5 minutes. So, who was first? I don't know.
So thank you for this work. It's really appreciated. I have a couple of questions. So I looked at there's some plans to have the site tag support for the packet CI because in many cases we have to build many packages and by providing the pull requests we don't want them to be built against Scratch built against like 42 or rawhide and so on. This is not working yet, right?
Just for the packet automation part that works, not for the
CI part.
CI, I think we need to think about that use case maybe more because now it's like multiple dependent pull requests, but we have some kind of feature like dependent PRs on upstream. So I would maybe like to discuss your use case in more detail.
Ideally, if this would be similar to what we have in GitLab CentOS workflow, that would help because many of those maintainers are also Fedora maintainers. So using the same syntax and using the same workflow would really help.
I'll probably get in touch. Thanks for
and that is using, I think, like changes in description where the information is being parsed out.
Okay.
I think that's technically definitely possible for that CI. So we are ready there to like deal with multiple builds in a single testing. So like from the testing form side, it should be completely fine. Okay.
I'm sorry if I didn't quite catch one of the last things you said. So the GPUs that you have available for AI testing, that's all AWS or is that now hardware?
No, it's all AWS. Like.
Okay, so that answers my question about AMD GPUs.
Yeah, unfortunately.
Okay.
Yeah. No, as we talked, we are looking for like somebody who will give us the hardware so we can actually enable more flavors of this. Steph?
So it's very cool to see this. What is the incentive or expectation for projects to onboard with using Packet as their dist-git CI? Is there an inherent incentive, or is there a change proposal coming where everyone has to do X, or how does that look?
Like as part of the change proposal, this will be this will be switched for all the packages around like August. So we don't have any change like to like onboard people. It's more like that we are like promoting that please opt in, provide feedback, and if I hope that we'll have enough feedback to be able to like switch the defaults and enough like input.
But there is a change proposal, like Fedora change proposal.
Yeah.
So, next question. You described the Fedora dist-git CI doing Scratch builds and then testing them. There are draft builds coming to Koji in Fedora, right? Is it on the roadmap to switch from using Scratch builds for CI to use draft builds instead?
Take a look at that. Yeah, thanks for the
I think that's a wider change, right? Because it's also like changing a little bit like how you are like promoting builds. It's like it feels like a larger change than only a CI change. But like we are doing that in for RHEL or CentOS Stream, so it like we should be ready, right? For us, it's just another build, and I think like I didn't see a proposal. Is there already a change proposal for that in Fedora?
No, I was expecting that it just will be getting as an update to Koji anyway, and then it's up to us to think about whether we should start using it. But probably someone else in that room knows better.
Yeah. Definitely that guy.
So yeah, definitely we can discuss that how we can expect this will work, so we can maybe be better prepared.
Yeah, draft builds are in Koji right now. It already exists in the one that's deployed, but right now there's a policy that they are not allowed to be tagged in any tag because there's no idea of how to use them yet. But yeah, a change to do that would certainly be possible. And I had a quick question, and maybe it's kind of a niche thing. With some of the other CIs, we had an issue where, take for example, there's an LLVM PR, and somebody submits the PR, and Scratch builds start, and then they go, oh, I missed this, I'll rebase this, oh, I'll rebase it again, oh, I missed my comment, and then they have like 10 rebases, and there's 10 Scratch builds continuing to run. Is that something you took?
Actually, in general with Packet, we had this as an issue number 7 or something like that from the multiple thousands that we currently have, and we've actually picked that as an epic for the last months, and so we've actually started skipping like the Koji and also Copper builds. Not sure which ones are currently, but we are working on that.
It's a similar solution that like somebody is doing the rebase, also hitting 10 testing farm, right? Like when the build get built. So I think the right solution is to cancel those previous
We
builds.
postponed that, but we can't postpone it anymore.
Are the builds x86 only, or are they multi-arch?
I'm not sure what we are actually running. I would need to check, but I think that's the same thing as Fedora CI is doing. So yeah, so we can maybe take a look if this is needed. And Fabian is like stopping me. So. But thanks for the pointer.
We have only ARM next to it, like available, so like infrastructure-wise. So we can work on that. So we have it. Thank you.
Yes. Oh yeah, I can do that. Okay, I guess we can start. So, hi everyone, I'm Mirka Konečný. I will tell you a bit of what we are doing with the web UI and what we are planning with the web UI mainly. Sorry, my voice is not perfect. It's much better, hopefully it will be fine and you will understand me well. So, I'm working on the Anaconda team and as the product owner and engineer for last 10 years in Anaconda. And this is one thing, big thing we are getting to deliver. So, about the presentation, I will share you our idea of the roadmap. But what I want to get from you is your feedback on that. We are really looking here for if we are not missing something, if we don't think about something wrong. Like, I'm working in Anaconda 10 years, and I'm still able to find use cases which I'm not aware of, because like it's quite an old project, and people are pretty innovative in how to use it. Just for information, when I try to get this image, I'm basically using AI for that, and usually when I'm trying to create a presentation that Snake is doing something, it's always put the arms there. So yeah, you're doing it wrong. So if you see that we are doing it wrong, please tell us. Yeah, so first I would like to, just for people who are not aware, who are not doing installations so often, I would like to give you, show you a demo of what we have right now in Fedora 46 live ISO. Hopefully it will work as it should, and I will get it there. Hope so. What is it? Screen. Ah. So, give me a second, I will move this away. It broke. You should have a live demo always, so you can embarrass yourself. Yeah, let's try to change. That is not, that is not, I don't want to go full screen. Let's try to change the, come on. Yeah, I don't want to do that. Let's try to go with this. Put it back, but I guess it won't happen. Okay. Let's try to move to start it there again. Yep, and it works. So basically, this is the WebUI installer what we have in Fedora 42. I won't go into too much details because I don't have much time, and I would like spend it more for questions, answers, and feedback collection. But yeah, it's based on the cockpit and Patternfly. One of the reasons is like for the consistency with other things with Red Hat, but also like the support for this technology is great, and like even for getting like testing, automated testing, etc. Like cockpit team is helping us a lot. So it's really in much better shape. So basically, what we have right now, you can select the language, so keyboard layout. You can select disk you want to install to. And we have a new approach for doing the installations, like for getting like selecting your path, which is should be more accessible for people who don't use installation or doing installation very often. And you can also like start cockpit storage here, which is taken in level of, you can do the partitioning yourself beforehand with any application and just go to mount point assignment or pick a path that I want to reuse that. Basically, I want to use that. I will just show you the cockpit storage, just what is there. It basically looks like this. I won't go into details because I don't have time, as I said. Feel free to take it, play with it. Hopefully you like it. And let's just continue with reinstallation of the Fedora, which is honestly new for WebUI. And as you can see, we have a warning that it will break your system, which is understandable when you are reinstalling the system. By the way, just the reinstall Fedora, it basically means that your home partition will stay intact, even though please do the backup before doing that, because like everything is new, and even if it's not, it's just a good idea. Okay, let's move it back. And here we are. So back to my presentation. So I will be talking here about the future of the Fedora. Fedora for the Anaconda WebUI, and this is the idea of our roadmap. So for Fedora 43, I will go by Fedora for a few, and basically tell you what is our idea. So the first one is basically in Fedora 42 we have workstation enabled with just the Fedora workstation. It was the like first baby step for us to getting it there, and we are trying slowly approach it and collecting the feedback during the path and reacting based on that. So the Fedora 43 is basically another next baby step. We are missing some functionality in the web UI. Some of it is already created, some of it is missing completely, but it's not used in the production right now. So we are targeting spins and KDE edition. And what we need to add is to resolve the keyboard selection a different way. Time and date is not configurable right now. For workstation is not that necessary because there is no initial setup. And the same for user creation. And the last one is kind of interesting one because we got already feedback that we need to enable custom browser. Right now we are using Firefox with our adjustments to like not having decorations, etc., etc. But there is a spin LXQT, if I'm not mistaken, which don't have Firefox. So for this specific reason, and also in example of, for example, Sway, if you have a Sway, you might want to have a special decoration, special behavior for the window, but like Firefox is not a other instance of Firefox. It's just like other Firefox if you want to touch it, if you want to configure it for this. So there are like multiple reasons of you want to have your own browser, your custom thing. However, I have a question mark there because we yet were not able to resolve how we want to approach this completely. There's a question who will maintain it, how we will enable it, if it will be on configuration of the configuration files of the Anaconda. Like there are a lot of question marks, so it might be that we won't go with this for Fedora 43 if we won't be able to resolve these. And also, we are fine with not like reaching out to all the spins. If we miss some, that's fine. It's more like optional thing. We would like to get all of them aborted, but it depends on like the specific needs of the spins and KDE edition. So we will see. The second part is uBlue. I unfortunately missed the presentation the first day for Universal Blue, for Bezite, but they are working on enabling web UI for a long time already. And thanks a lot for getting us feedback all over the years or the time. I need to talk to you. Unfortunately, I wasn't able yet here, but we definitely need to sync. So far, based on my reaching out to them, it seems they don't need any special actions from the web UI from us. But it might be that I'm not correct here, so I need to talk to you guys. So for the Fedora 44, we have our goal is to go with Atomic plus enabling remote browser installation. Gives sense. It's HTTP technology basically because Cockpit is like it's web-based, so you can start the installation from remotely, basically on like enabling any browser on any device you want. With a skipping here, but I will finish it. So basically, we have this already for remote installations. We are using that for automated testing, but it's not mature enough to make it publicly available, like let's use it everywhere, because for example, we want to enable HTTPS, and we don't have yet generation of the certificates and similar things enabled. Maybe also user authorization, as like if it will be HTTP server, it's great, it's accessible everywhere, but it's accessible everywhere. So it might be that someone will join for your running installation. You don't want to do that. So that's something we need to resolve, and we would like to, for Fedora 44, enable it. If you want, you can use some boot options and play with it even now, but it's just like plain HTTP, and it might be struggling sometimes. And also, we would like to onboard Atomic desktops. That's another goal, again, with level of, if we enable spins and KDE edition, we should be on good path to enable also Atomic. We might be also doing that like from the perspective of feature requirement, we might be able to do it in Fedora 43, but let's keep it like reasonably distributed, avoid doing everything in one release. And we have an optional goal there, which is networking. We have it as optional because for atomic installation is not really necessary, because like atomic installation, atomic ISOs are installing from local DVD, from local ISO. So you don't need to have a network to do the installation. But on the other hand, the networking is a big question mark for us still, because we are not 100% sure how we will handle it in WebUI. There are a few ideas of using like Cockpit, what Cockpit has, etc. In GTK-UI, we used an connection editor, network manager connection editor application, but they want to basically drop it. That's first part in RHEL and CentOS, etc. That's first thing, and second thing, it's like not really usable with the WebUI technologies in level of it would look it's usable. You can do it, but it would look just bad. You don't want to do that. So we are still thinking how to do it. Like networking is a big topic because there's like a lot of configuration, VLAN, bonding, etc. Like it's not that easy, and we don't want to ideally maintain it, like create it and maintain it ourselves, and more put it on someone who's already doing it and doing it correctly, if possible. Then for Fedora 45, that's our, like, I would say ultimate goal, server edition, because server edition has currently in the current form, it has almost all the functionality which we have in the UI. So it needs networking configuration because we are doing remote installations. It needs, it is a must-have. Hopefully we will deliver it before. It needs software selection, environments, groups, selection, source configuration. That's a question mark a bit, because I know that basically we are, for most of the ISOs, you are using Fedora repositories as by default. So this seems to be a bit maybe like not necessary, but again, we are looking for feedback if you see it otherwise. And another big thing is the partitioning. We already have something, but it's not used, it's not finished, but we basically need to enable multipath, FCOE, iSCSI, NVMe. There's a lot of technologies where like these are used in enterprises, and Fedora Server is using it, these two most probably. And we would also like to enable in the guided partitioning scheme selection, because like ButterFS is fine for workstation. They were even like said us that if we enable something like that, they wouldn't like to have it more hidden or advanced, because they want to have like the default ButterFS. But for the server variant, I think LVM is like often the choice. LVM Tinpool, the same. So we would like to enable like easy installation, but with selecting what technology stack you want to use here. And we are also thinking and looking into how to enable better easier software RAID support. Like you can do software RAID with cockpit storage, which will be the ultimate goal if you want to fine-tune everything. But for the guided partition, there could be something like I want to install it automatically, but I want to use RAID 1 for it, and we will like create the automatic partitioning for you this way. That's the idea we are thinking of. If it will get there or not, it depends on availability or like on the resources, etc. We will see. Also, if it's like really feasible when we try to put it together, if it gives sense. And after Fedora 45, that's the best question mark. Honestly, we don't have a roadmap so far away, but in the long-term future, we are thinking like we don't want to maintain multiple GTK UI, multiple UI, so Web UI together with GTK UI. Also, GTK UI is built on GTK3, which is I'm not sure when, but I guess it will be end of life soonish. So there's a question mark about if we even are able to get it into RHEL for future, for example. So that's something basically where we would like to drop it from the maintenance. But if someone from the community wants to take it, like Anaconda is currently designed in a level that there's a UI and we have a backend, and backend has a dbus API, and both of these UIs are communicating with the backend. So it should be feasible to just like merge it or get it out of the Anaconda code base and separate it as the separate project. If someone wants to keep the GTK UI from the community, I don't think there should be a like strong reason to block it. So yeah, that should be fine. And we definitely want to reach all the other variants, and like I would say mother of everything from the feature level is basically everything ISO, wood ISO standard. So if we go like we have everything, we are after the server, everything is adopted, then we can go for everything ISO. That should be the last ultimate goal of like we have a UI everywhere. And ideally, if we slip like some spins or something, we can get it there too. That's for future. Like we don't have. It doesn't mean it will be in Fedora 46 or something like that. It depends on situation. It's too far away. So this is just the overview of what I said. So you have it on your eyes, and right now, I think it's place for questions. So questions, feedback.
Thanks for the great presentation. I really like the new UI. I had just one issue with it. I have this habit of installing like Fedora on my relatives' computers, and lately I was installing it on a 10-year-old notebook like it that had two cores of CPUs, 4 GB of RAM, and I was just trying out the normal UI, and really the new Anaconda installer is so slow that like it takes like I don't know 5 or 10 minutes to even like start. I know that spec is really bad, but like compared it, and then I installed some spin which is using still the old interface. So I was just curious if you are aware of this issue. I should file it because really it was like the experience was like so bad that I think it would definitely discourage people to install it.
Please file it. I'm not aware of it, but in general, you should be able to install it reasonably well with the remote web browser access. That would happen. I don't think it should happen, honestly. I don't know what happened there, so please file it and we will see if we can improve it.
Get the hardware easily back. So thank you.
Thank you. Yeah, also if you want to, please go ahead.
The microphone, so I can ask question too. So is that something you want to roll slowly and as an option? So you still have Anaconda GTK available, and at one point you want to switch the default to Web UI?
Yeah, we are basically adopting the variants for default. So Fedora Workstation is already using Web UI on Fedora 43, and as I went through it, then we will adopt it slowly this way. So basically we are changing the default one step for another, one ISO, one distribution for after another, and that's the goal we are looking for. Because like enabling it everywhere, that would be first like we would have to do much of the work at once without no feedback, no possibility to react, and second, like the GTK UI would move during that time, and it's like hard to keep track of like the changes on both sides. We are not that big team, so it's.
Meaning that in fact the roadmap is just about the UI, but all the functionality are still in the back end. It's
yes.
Like for example, a kickstart file would continue to work for
yes.
very complex storage configuration.
Definitely.
Okay, good.
Definitely. Okay. Like that's the benefit of vSplit. We working on modularization. There are some old presentation from last years about the modularization in Anaconda we are doing, and basically it means that we move the logic into the modules which are Python applications with the dbus API. And right now the GTK UI and also Web UI are basically using this as the communication layer. So the backend is not changing.
Thank you.
Well, as server, I see we have a year time before we are hit by the news, and I got enough nice. Other question is, if you have to make special adjustment for the browser in Zwei, do you have special requirements for the remote browser, or is it browser agnostic?
Yeah, like there are no special requirements of what you need to have from the browser, but we need to definitely design the API correctly in level of something might not be accessible. For example, we are thinking of the network configuration. That's a nice job, nice example, because you can just easily cut yourself out by going to network configuration and misconfigure it. like you have a dead machine somewhere and you have to go there yourself and reboot it or something. So we are thinking if we won't like go in a way of disallowing to change the network configuration in the web UI, just because like avoiding these situations. I don't know, that's, as I said, there's a question mark. But in general, like, I don't think there are special requirements for the remote browser. But that might be also a question for a cockpit team. As we are using their framework, they should know about.
Anaconda and Cockpit share the same stack, and Cockpit targets like the common browsers. So there is a Firefox, Chrome, whatever it is. Of course, if like common browsers concept changes, then we will change with it towards like the common goal. Like we definitely don't want to have any like specific Anaconda browser requirements. That's just a generic web application. It should be normal. It should be like as any other JavaScript site out there. It doesn't have to be very special.
Yeah, just for information, why we choose the Firefox, it's basically because of availability reasons, because on RHEL there's basically no other options right now. And that's the reason why we are sticking with it. We don't want to support multiple browsers in general, like even the custom browser, it most probably will live in like if you do that, if you use that, you are maintaining your own custom solution. Because for us it would be super hard to keep like everything.
No other question?
If no one, nobody else. What about the software rate support? Currently we have a support, of course, but where the EP partition is a bit out of standard, because we have to define it as a RAID partition instead of a AV system partition. It works, but well, it's non-standard, so to speak. Do you want?
It depends also on architecture.
Will it?
It depends also on architecture, basically, how it works, if I'm not mistaken.
Yes. Do you want to change, or do you plan to change something in that area, or do you leave it as it is?
Yeah, it's like, if I understand the question correctly, it's not about directly web UI, it's more about the backend logic for if we allow it or not. Am I correct?
No. It's if you want to configure a RAID on your server, you have currently you can't create EV partitions, but you have to create RAID with the EV file system. That works, but it's not. I think as far as I know, I'm not an expert in that area. It's a non-standard solution.
That's a good question. Like honestly, I would see it in a way of for these specific cases, because if I'm not mistaken, Anaconda by default is not doing that right now, because it's not. I believe it's working, but it's not the recommended way of doing it. Like the boot partition and the FE partition and similar things should be out of RAID, and it's not supported on all of the architecture. But you can do that with the cockpit storage, most probably. I'm almost sure you should be able. So you can do it in this like customized way of things, like doing it yourself. But I don't think we will enable it in the guided partitioning, like the easy way, because it seems to me like this is not the recommended way. But I'm also not an expert for software aids and similar things, so unfortunately, I'm not sure if I'm saying 100% correct. We are out of time. Okay, so we are out of time. Thank you a lot. Also, if you have any more feedback, we are around. Please reach us out, or in the presentation, I have links on metrics and on our mailing list. So please feel free to reach us if you have any idea, question. Thank you.
Okay. Hello, everybody. Thank you for coming. Today, this talk will be on the server edition of Fedora, how people use it, in what environment they use it, and how we discovered all of this. So, yep, okay. My name is Emmanuel Seyman. I work for a company that is in the insurance business that has requested to stay anonymous. This means that you can find out its name by checking my LinkedIn profile, but never mind. This company has a heavy reliance on RHEL, Red Hat Enterprise, but at home I use Fedora, and since I have a couple of SBCs at home that I tinker with, I use Fedora Server at home.
I'm Peter Boy. I'm a sociologist by major, and my minor is applied mathematics, which was a home for computer science, the academic home for computer science at the beginning of this year, 1,000 years. Well, 20 years ago I started to organize, as a side job, so to speak, to organize the IT equipment of various of our research departments. I started with AIX as a middleware, but we soon switched to Scientific Linux. And when it's a mix of Scientific Linux and Fedora, the usual case, we need this newer software, something like that. And when Scientific Linux were keys down, I had a short trial of CentOS, but then switched everything of our servers to Fedora. It's not such a great number, it's 25 boxes about. But I didn't expect any degrading in working, in stability and so on. And so I'm convinced Fedora Server is a good solution for the normal everyday server operations. And that's the common goal of the server working group as well.
Okay, about a year ago at last year's Flock, we realized that there was a lot of things that we could do, and we didn't know whether our users would profit from this work. Well, which part of this work would profit our users the most, because we had no idea what our users were using Fedora Server with, or in what environment they were using it. So we came up with the idea to create a survey, promote this survey in Fedora magazine and at events like FOSDEM, and encourage people who use Fedora Server to fill this in so that we could have a better idea of what they do. One of our members, Stephen Daly, Mo West became the point man for the survey. So we went through a couple of iterations. We decided to limit our questions to 10 questions because we didn't want people to give up halfway through the survey because they realized there were 25 questions and they were going to have to spend hours filling it in. And the results.
Don't be too excited about it, probably enterprise-centric. About the enterprise-centric, because the blue line the blue color is a nose. You know, the nose habit. Unfortunately, at the first sight, I was happy, but a closer look at them reveals the problem. Well, nevertheless, as I told you, we are focused on the professional use of Fedora Server. And so we are quite happy. We are in the enterprise. It's about 5 or 10%, not that much, but we are bleeding edge distribution, and so I think it's a good idea that we have at least 5 to 10%. And we have a good representation in the professional use professional use, and the definition here means using in a home office, using for professional development, using in small to medium businesses, I think is the word, that in that region. Well, and our big surprise was the last line. Of course, we were aware that Fedora server is used at home, but we didn't focus on it, and well, we expected some usage, but not that one. About 90% of the participants were using Fedora server at home as a home lab, not home lab, as a home server. About home lab is our definition. It included private development, as not professional development, but private development. Well, it was unexpected in that extent, and we did the survey in order to better fulfill requirements, expectations of our users. So we have to refocus a little bit. On the other hand, we wanted to stay with our focus on the professional usage, of course. We are known as upstream Red Hat enterprise, and a home server focus would be nice, quite well, misleading. So we came up with the idea to keep the focus on the professional usage, the top two bars, and to probably introduce a home server spin-off of Fedora server. It's in the discussion. We are not, but I have to look for my list. Wait a moment. Yes, it's in discussion. Nothing is decided yet. We want now to start a discussion about this. Well, if we do a home lab spin-off, we don't want to create just another boring device, so to speak. We want to create something dedicated, something special. Various ideas are around, for instance, environment friendliness, so we can concentrate on low power consumption and less or low heat emission. Of course, affordability would be a criterion. Definitely we intended to be a replacement used for the right usage of commercial NAS mini servers. Our hypothesis is Fedora tools, especially Cockpit and Ansible, offer a similar easy-to-use administration as these commercial boxes, but they are lightweight, perform better, and especially they are perfectly customizable, which commercial boxes definitely are not. Well, and we want to provide a real ready-to-use installation, pre-install a typical set of software, but we don't know what the typical set is, but that's a question of the community. And of course, we want to rely completely on Fedora-based software, not something external. And my idea is to try to, well, it wasn't our ideas, but I started it. I have some experiences with so-called participated software development, that is, to include potential customers in the development process at the early stage. I want to come up with this methodology and try it out, if it works for Fedora or in Fedora, and if it helps us to broaden our user base. Well, and the current plan is to initially start with 2 ARM devices, 2 RISC-V. I did some experimentation with RISC-V. It's early stage, but it works. And the N100 mini server, something like that. And really mini server, for instance, something like Urine, we have an N100 processor too, and are quite affordable. That's the current discussion. I don't know where it leads to at the moment, but we will start hopefully broad discussions in the net. Well, that's You are the next.
What I was interested in the survey was what people use Fedora for. Once they have installed it, what do they load up on it? This is the responses we got. This is more or less what I expected. I knew web applications were going to be the most used reason. And some of it is disappointing, considering how good Fedora server works as a domain controller. I would have expected it to be higher, well, lower on the list. Hi, Alex. And I'm sorry? I want to add a bit of note here. Can you give him the mic?
So don't get spoiled by these numbers, because you don't need to have as many domain controllers as you want to have application servers. So you, for example, in FreeAPI, we typically recommend to have 2 domain controllers per several thousand of clients enrolled into it. So you get this ratio going there. So we see here like 10%-ish of the overall base use it for organizing the network. And that I would say abnormally high, actually. So this is the interesting part out of this review. Yep.
Where was I? Yeah, this is more or less what I expected. Domain controller, FreeAPI came up quite a lot. Game server, a lot of people use Fedora as a Minecraft server, interestingly enough. Web server is all over the place, from Ruby on Rails to Perl, going through Python, Node.js, and everything else. Backup server is Duplicity, something called Borgmatic. Some people just use rsync to upload stuff. And anyway, this is pretty much what we expected. And since one of the goals of the Fedora server SIG is to provide Ansible roles for whatever you use Fedora server for, this is going to be, well, we're going to prioritize certain Ansible roles based on this data. So we had a number of questions. One of them was, which feature do you wish was part of the Fedora Server Edition? Which is the one feature you would want. Out of 587 responses, 330 people did not reply, which I interpret as saying there is little to improve in the edition itself. Of the 257 other responses, more than somewhere between a third and a half of them explicitly said there is little to be changed in the edition. And the rest focuses on having a minimal install that is even smaller than the current minimal install. Some people want OpenZFS, which I'm not sure is going to happen anytime soon. Some people just wrote the word ButterFS, which could mean that they want it to be the default, or which could mean that they want it removed from the list of file systems that you can choose from. Four or five people mentioned that they wanted Raspberry Pi 5 support, because the P5 is much more powerful than the P4 and can be of much more use as a server than the previous generations. And others, some people wanted more cockpit integration. Some people wanted cockpit not to be part of the main install because they really like their minimal install to be as minimal as possible. And yeah, Stephen, please give him the mic.
So speaking as someone who had been on the server working group from its inception, the minimal install is not server edition.
Oh yeah,
I think that
yeah, absolutely.
I think that may be a thing that we didn't make sufficiently clear, and I've actually dabbled with the idea over the years of actually taking the Fedora custom OS option off of the install media, just to make it clear that what we are selling is well, we're not selling, but what we are providing is a curated, opinionated package set, not a playground. Exactly. You should, if you get server edition, what you're getting is a certain minimum set of functionality that you can always expect to be there. So, well, that was my highly opinionated reply.
Someone behind you wanted the mic.
Just a quick question. If you take minimal off, that's the only reason I use server edition. Where else would I get minimal?
Well, so the network install for Fedora Fedora does include the option to pick something minimal or custom, but at that point it's the everything installer allows you to do nothing, to install basically nothing as well. But yeah, if you're
so we were talking about this yesterday, and we realized that we were never going to make everybody happy, and so case in point. And another part of the reason we want to promote Ansible roles and playbooks is to allow people to customize their instance after installation. So something like software removal could be part of that.
Yeah, documentation.
We also asked people what they wanted to see changed in the documentation.
Documentation was my entry in the engagement in Fedora's edition server, Fedora server edition, until I grabbed myself deeper into the issues, deeper as initially think. But I'm quite content with the reaction to documentation. It is the path, exactly the path we are trying to develop the documentation for the last 2 years about. I'm a bit astonished about, Podman is okay, but a bit astonished about Kubernetes. We hadn't, well, we weren't aware of it. We had been, but we are not. And the same with Kickstart. Well, we are aware of it. It's on the plan for a year or so, but until now we didn't find someone to write the documentation. But it's a new incentive to urgently find someone to do it. And there's another short notice issue with or task of the documentation. Web services is the most used service in Fedora service, and Fedora, unfortunately, is quite outdated in its web service support. We install just like 10 years or 15 years ago, we have a main web server, and we don't install HTTPS by default and something like those. So, well, I wrote a backup more than a year ago, but it ended as often with Fedora, there are no resources, and the bug was closed with a new edition, with a new release. So we are using currently what we start to use documentation and the Ansible support to fix something which we have to fix in the RPMs, but it doesn't happen. The issue is if you install the default, if you use the default installation to set up one server, you get a different you get a different document root, and you get different name services because our default installation installs a default SSL virtual host, but a default virtual host it doesn't exist anymore. It was Apache 2.3 or 2.2 or something like that. Since then, there is no default server anymore. So we have used documentation a bit to fix some things we should fix elsewhere. Okay.
Yes. Okay. Before Q&A, we wanted to thank some people. Steve Daly, who is not here because he's American and didn't want to make the trip, was the point man for the server SIG. He spent an enormous amount of time on the survey, refining it over and over again until it was finally ready. We also want to thank Justin Wheeler, who is running around somewhere, who gave Steve access to the Lime survey server so that he could publish the survey, and who gave both of us access to the results so that we could actually prepare this talk. That was back at FOSDEM. And finally, we want to thank everybody who participated in the survey. This is very useful data, and we are going to put it to good use. And finally, questions? Anybody?
I have more comment thing. I feel it was very interesting data, and it seems like people are interested in more like profiled use of server for specific purpose, and you're interested in creating these examples. So on behalf of Cockpit project, I would say we would be really interested in finding ways to describe this higher level use cases, because Cockpit right now, I think, works on a lower level. Like you have storage screen to configure storage, you have like networking screen to configure network, but you don't have in Cockpit a screen to configure Luanti server as a game server, right? And you have this use case where Fedora server is used as Minecraft, but like let's talk Luanti instead. And so I think the interesting development of this would be to figure out these higher level use cases and to create dedicated set of like plugin for Cockpit. And also with this web UI effort now, we can basically reuse, if plugin is created for Cockpit, we can reuse it in the installer. And again, if you're installing Fedora server for Luanti game server, you would be able to basically configure your Minetest installation from that screen and then like manage it from the Cockpit screen. So this would be, for me, a very interesting development of this whole concept.
First of all, in the others category, in the documentation, we had people who wanted to know how to develop extensions for cockpits or modules for Cockpit. I really need to go through the survey and send you feedback.
So Cockpit actually has the starter kit repository on GitHub, which is your like boilerplate for a plugin. You clone it, and then you add like 3 lines of HTML and you create a page in Cockpit. I did it myself. It was actually quite easy. So take a look.
Well, it's most interesting. Stefan and I, we had a discussion yesterday just about that. And but to my knowledge, Cockpit is too far away, too complicated, it's very different. But I see I'm probably wrong, or I'm hopefully wrong. So give it a try. I will come to you with an example.
So one thing related to that is that we have plenty of documentation elsewhere. We have plenty of documentation elsewhere in the upstream projects everywhere. We have very bad way of discovering that. And especially with the search engines going in wrong direction by not really promoting the actual content that people can search, but promoting some artificially generated crap
Yeah,
of that content. So the documentation linking within the Fedora server might become a very useful point, a focus point for the people to discover stuff like what Alexandra were talking about with the, like, okay, how I can extend or configure screens on my Fedora server. Here's how you find the starter kit for cockpit integration, and point to their upstream documentation so that people go and start with the Fedora server documentation and then discover, I don't know, Samba, FreeAPI, Cockpit, and the others documentation. It will certainly help us to centralize the thinking through use cases, because then we can control what we put under those use cases, how we structure links to that external documentation where needed, and so on.
Just a short answer. It's my docs engagement. It is, yes. The rule is, or I try to establish a rule, always to add a link to the upstream project in each of the Fedora documentation, and to limit Fedora documentation to those things which are specific for Fedora and not a repetition of general upstream documentation. But my power is limited, so, and I forgot that myself at the beginning. I'm on the way to add these to the Fedora documentation. Yes. Okay, thank you very much anyway.
All right, I think we can start. Wow, so many people. Good morning, everyone. Welcome to the Multimedia in Fedora talk. Here's what I'm going to talk about. I hope there will be a lot of questions. There usually are. First, a few words about me. Well, I've been within this community for a very long time, but there probably are still people, hopefully there are many people who still don't know me, so I'll tell you. Then we'll go on a journey through the history of multimedia software in Fedora. It's quite a long one and with many twists. Then I will tell you what we can't have in Fedora yet due to various reasons. And then I will show you what we already have, and it's quite a lot. When I was preparing this, it's kind of jumped at me, wow, we have so many things in Fedora already, which is great. And then, if you're interested, I will suggest a few ways to assist, help, and participate in making multimedia in Fedora better. All right, so let's roll. About myself. For those who don't know me, I've been an open source contributor for like 25 years now. If you go to the Open Hub, you can see that, for example, my Fedora contribution started around 2006, but before that, it was actually multimedia that got me into open source contributing because the first thing I worked on was mPlayer. So who in the room used mPlayer? Yes, thank you. So yeah, that kind of got me into open source a lot because it was a fantastic community. Sometimes a bit rough, but yeah, I still remember it fondly. Nowadays, some players a bit like how do you call it? Unmaintained, let's say. MPV, I think, took the place of mPlayer. But yeah, I also contributed to a little bit to FFmpeg, the DVD access libraries, the extended module player. Who in the room knows what modules are, music modules are? Okay, there are some, great. Yeah, this is back in the day when multimedia on PC was still becoming a thing. Before that, we had like the personal computers of that era, like Amiga, Commodore. So there were many people who created music on those, and I think the Amiga demo scene or music scene became the most vibrant, and the modules come from that space. They had those software programs, applications, we can call them now, called trackers, and they let you create sheet music, and there were like tens of different formats that music was stored in. So there are quite a few programs for Linux, for example, that can play those, and XMP is one of the best. So when I found it, I did a little bit of work there as well. So then I started studying, then I even worked at the university, so that's where I got the scientific software part. I was friends with many scientists, and they used some software. They used Fedora, and the software wasn't packaged, so naturally I helped with that. So there are a few software packages still in Fedora that were originally created by me. Nowadays, I don't work for the university. I don't meet the scientists so much anymore. So there was no point in me maintaining them anymore. I gave them over. There are quite a few people still doing scientific software, so they are in good hands. So nowadays, my main area is multimedia. So I actually established a multimedia SIG, and I also served on the Fedora packaging committee, did one term at FASCO, a very interesting experience. I recommend everyone to try. Professionally, I have over 20 years of experience. As I mentioned, I worked for the University of Warsaw. I did 1.5 years at CERN. I also recommend that place if you can go there. And now I work for Citi, which, like one of our previous CEOs said, is an IT company with a banking license. So also a great place to work. So yeah, I've got a bit of experience, especially in this community. So multimedia is my favorite topic. So how did we get here? It's a long story. It starts much earlier than this table shows, but we have to start somewhere, because otherwise I can talk for hours about this. So we didn't have everything we wanted even back then, especially back then in Fedora. So a few people here and there established like third-party repositories with packages that weren't in Fedora. So one of those was Fresh RPMs, another was Livna. There were quite a few people in those two communities. And they were established in the early 2000s. Around the same time, GStreamer got into Fedora, and also the first royalty-free or not encumbered by patents codecs like Theora or Vorbis. Theora is for video, Vorbis for audio. I was looking up some interesting software that people might recognize. So who in the room used XMMS for playing music? Yes. Sorry? Yeah, okay. But in 2005 it got into Fedora and we could play some music. Then next year we got Zine. And the following year we got a new royalty-free codec called Dirac. I think it was funded by the BBC, but I don't think it went anywhere. It didn't become popular. Too bad. The same year, the project that I'm still part of, RPM Fusion, the third part, like the most popular or essential third-party repository these days. So we started back in 2007. It was a merger of those two that are listed, Fresh RPMs and Livna, and one another called Dribble, but that was primarily for games. We tried to get other like RPM Forge, like 80 RPMs, but there were some, let's say, creative differences that caused that not to happen. This is mostly where the history begins. Then we got more and more multimedia software, like the second edition of XMMS and the QMP. I think that's a player for with the Qt framework. Then new codecs appeared, finally. Those that got more popular, VP8, VP9, there was some FUD about them that they may be still patented or covered by the same patents that are there for H.264, but nobody challenged them in court, fortunately. So yeah, they are still with us to this day. VP9 especially, it's like I think most of the videos on YouTube are encoded to VP9 by Google. And an audio codec, Opus, was also added to Fedora next year. So now you could actually watch all YouTube because Google started encoding everything to the royalty-free codecs, and now all material is available in those free formats. So then there was a little gap, and not much happened in the multimedia area. Then Cisco came along and bought everyone a license. So the whole world could use their code, their binaries, to decode and encode H264. This is open H264, which we have in Fedora. Nowadays, it's causing us a little trouble, which probably some of you are aware of, but yeah, we're thinking of how to deal with that. Next year, MP3 came along. Finally, we could have it in Fedora proper. Yay. That was imported from RPM Fusion, of course. Yeah, that's the first part, and I'm going to take a small break to drink. Okay, this is my favorite. So then we started getting more and more codecs that were previously not possible to have in Fedora, like AC3, which is mostly found on DVDs, MP2, which is MPEG-1 layer 2, a version of AAC, a little stripped down, because it doesn't play correctly some of the files encoded with a high efficiency profile. But yeah, I did the package review of FDK AAC3. It was a bit controversial. Some people were against it. I was against it because it silently played the files wrong. But FESCO decided it's better than to have something than nothing, and it also unblocked some other things. So, well, there was no technical reason to block it, so it went in. Of course, at the same time, we did a counterpart in RPM Fusion that provided the full version that was parallel installable. And then major development, AV1. It's like, I think it's actually gaining popularity a lot. It's present in hardware decoders on GPUs, modern GPUs. So, in my opinion, that's a lot. Okay, so then we got some other codecs like the Bluetooth one, LDAC, MPEG 1 and 2 was possible as well. And then Andreas came and figured out, together with some other folks, what we have to strip from FFmpeg to be able to get it into Fedora. So, and finally in February 2022, we got FFmpeg in Fedora. And that's like a game changer for me, because now practically everything that wants to do multimedia uses FFmpeg one way or another. So that unblocked like the whole world for us, and we could start bringing in stuff from RPM Fusion and package new stuff that was depending on FFmpeg. So we got the MPV, the best player ever, or at least so far. We got video editors. More codecs were also possible due to patents expiring. Yeah, and like we got big names like OBS, Open Broadcaster Studio, VLC. SM Player is a front end for MPV, actually. We got yeah, all those other major software like OpenShot, Shotcut. I know many people use. So we got all of those. There are still some, but I'll talk about it later. An interesting development this year there are some new codecs, royalty-free, and one is called OpenAPV. It's supposed to be like the replacement or competitor to ProRes. And then there is MPEG5. It has two profiles. One is that we have in Fedora, that's royalty-free and not covered by any patents that are still valid. So we got that part into Fedora. And yeah, this month I'm talking to you, which is great. So what we can't have yet. The things I kind of hinted at. So 8.2.64, the only thing we can have is the Cisco implementation. There are still patents covering it. I think most of them are expiring in about 2 or 3 years. But, you know, with patents, it's tricky. Sometimes there are some that are not listed anywhere, or someone haven't found them yet. We have to be careful and just wait for the legal opinion that it is allowed. H.265, that's gonna take a bit more time because the patents are still there for many years. It's kind of sucks because like iPhone produces stuff encoded with 265. It's part of the DVB2 standard. So we're going to see material encoded in this for many years to come, and we still can't have it in Fedora yet. Then there are some new standards like H.266, aka VVC. There are some older codecs like VC1 that are, I put an asterisk there, and also with some audio codecs, the Bluetooth ones, IPTX for example, and DTS, that's for also the Blu-ray audio, because I heard rumors that they might be acceptable quite soon, so we'll see. All right, so what we already have in Fedora, and as I mentioned initially, it's quite a lot. So we have the major multimedia libraries and frameworks, so FFmpeg, GStreamer, Qt Multimedia. Everything builds on top of those. So we have that. Well, FFmpeg doesn't have some codecs, but doesn't matter that much. We have almost all the video players, MPV, VLC, Caffeine. There's one that I like very much that's for GNOME. It's called Clapper. It's like very small, I don't know, 2 megabytes or something, because it uses GStreamer, it uses GTK, so it's just a wrapper around everything we already have, and it's very nice. If you like minimal players. Then we have tons of audio players. I won't be enumerating the names. Everyone has their own favorite. We have video editors. We have audio editors. We even have subtitle editors. And I don't know how to pronounce it. Egisub is a new addition, I think last month. We have DLNA servers. I use Mini DLNA personally, for example. It works very, very well. So, as I said, we have a lot. Of course, there is stuff out there that you can help bring in. So, but first, tell people to use non-proprietary codecs, please. You can also come and join us in the Multimedia SIG. We try to co-maintain all the multimedia packages in Fedora. So there is also always work to do. We could use some help with getting the missing codecs in Fedora, like those with the asterisk that I mentioned. For example, for APTX, there is a package in RPM Fusion, of course, but from what I heard, there is an implementation that Qualcomm donated to the Android open source project, and that could be brought into Fedora but yeah, that needs to be researched. Of course, we try to work with upstreams, for example, with the MPG5 codecs. They built only on x86-64, and I think on ARM, but there were some issues. So I had to actually go and fix the CMake files so that they would build on S390X and PPC 64LE. So I managed to upstream that, which is great. So we need help with that kind of stuff as well. And of course, whenever anything is updated, new releases, please come, test the stuff, play your favorite videos, and report issues if you find any. So, all right. Time for questions. Wow. I guess I stumped you all. Yes.
I think you mentioned Apple. What about photos? HEIC, I think it is. The Apple cameras take now. That doesn't seem to be usable on Fedora.
All right. So you mentioned HEIC. Yes. It is usable if you because I think Apple uses H265 as the encoder for because actually it's called HEIF, although they call it HEIC. But you can use different codecs inside. And Apple uses the patented one by default, but you can use others. If you want to decode those, you need to get the free world package from RPM Fusion. And once you install that, magically it all starts working. Yes, it's supported. You just need the package that links libhave to the H265 decoder. For H265, I honestly haven't checked because they are years, well, still valid for many years. I only checked H264 because that's close by. Like we might be able to get H264 other implementations even quite soon, like next couple of years. But H265, sorry. But yeah, it's available. That's what I even mentioned in the description of this talk. That yeah, the iPhone videos out of the box don't work, but you're just one package away from getting all that to work. Okay.
So you mentioned there were a few codecs that are not available in Fedora yet. So where can one get them? In RPM Fusion?
Yeah, for now the answer is RPM Fusion, yeah.
Yeah, that is the GStreamer something package or a specific one?
So basically you need either the libav codec free world package, which is parallel installable to the libav codec free present in Fedora, or you can just swap the whole FFmpeg implementation and install FFmpeg from RPM Fusion, whichever you like, but you can just install the add-on. And the one for libhave you need also to install to get iPhone videos playable. And I don't think there's much more. I think there are a couple of plugins for GStreamer, but they only add X264 encoding. There's one for VLC, I think, as well, for X264 encoding. One major thing that's in RPM Fusion that is still not in Fedora is Handbrake, which I personally use for encoding or ripping, you used to call it DVDs. I did a proof of concept to have Handbrake with only 3 codecs, but well, when I mentioned it to the upstream, they were against it because they said, "Oh, but most of our profiles are for H264, It's 264 encoder. So for now, I'm keeping it in RPM Fusion, but I'm a bit, on the fence, because I kind of agree that it's better to have something in Fedora than nothing. Okay.
And another one, I was always confused by the naming on the RPM Fusion codecs, that there is GStreamer bad, GStreamer good.
Oh, it's not the RPM Fusion naming. It's GStreamer naming. So that they split their code into several sub projects. So there are plugins good, which are in Fedora and which GStreamer upstream considers like production quality, let's say, and then there are bad, which are, I don't remember the difference, but there are different reasons why they are considered bad, and then there are ugly. It's one thing is, I think, licensing, and the other is code quality. So it's actually GStreamer naming, not something RPM Fusion invented.
Thanks.
You're welcome. There's one question in the back.
Yeah, thank you for the overview. You recommended to use library codecs. Do you have a clear favorite that you say, okay, this one works reasonably well and maybe even has hardware support?
Favorite codec. So I think AV1 is that because it's gaining popularity with the anime fan subbing community, and like one of the MPlayer and FFmpeg developers said many years ago, codec development is anime driven. So yeah, I've been watching that unfold over the last couple of years, and AV1 is definitely gaining popularity there because it really cuts down the size of the videos, and the processing power caught up with the demands of the codec. And we have hardware decoding implementations of AV1 and even encoding in newest GPUs. So yeah, I think AV1, at least for now, if I had to say one now, it would be AV1.
So thank you for that. I think it was quite a great overview of all the codecs over there. I got a question about the packaging in FFmpeg though, because okay, so we have official, let's say, FFmpeg in Fedora, then we got FFmpeg 3D, we got FreeWolf from RPM Fusion, but there's also another one from Jellyfin developers. What's the status of all this? Do you plan to or try to put it all together at some point? I assume Jellyfin would be mostly related to hardware acceleration, but I wanted to know if you knew what this was all about.
Sorry, what was the third one you mentioned?
The Jellyfin one. The Jellyfin developers offered yet another FFmpeg package themselves.
Jellyfin?
Yeah. It's basically some kind of a BD application, some kind of...
oh, okay. I was not aware of that one. I mean, we have Jellyfin in RPM Fusion. Someone is trying, or was trying, to get it into Fedora. There was even a review request open. I didn't know it bundled FFmpeg on its own. So okay, so the split is like this. We can ship even some sources in from FFmpeg in Fedora, so they are stripped, and that's what we have in Fedora. FFmpeg has the full. RPM Fusion has the full sources, but the difference is just the codecs enabled in libav codec. So whenever we can have everything, and I heard rumors that we will be able to ship the whole sources in Fedora even, so the only difference will be the build options.
Gotcha, thank you.
And yeah, that's it. Okay.
Okay, we are out of time. Thank you, everybody. Let's go for some break.
Thank you.
going to play it now. Can you see what it sounds like? I'm playing a commercial right now. Is that not working? Jackson, the... Oh, actually, I bet it's not. User error. Yeah, I'll start it. She's fine to me.
Ram-a-lam, ding dong, ram-a-lam, ding ding dong, ram-a-lam, lam-a-lam, ding dong, ram-a-lam, lam-a-lam, ding, ram-a-lam, lam-a-lam, ding dong, ram-a-lam, ding, ram-a-lam, ding dong, ram-a-lam, ding, ram-a-lam, ding dong, ram-a-lam, ding. Ooh, ah, oh, 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 I've got a girl.
I think they're all dead, so I'm not sure. This song should be in the public domain by now. Yeah. Okay.
Introducing Remarkable Paper Pro.
Now we're going to run an ad. So how many people have ever heard that song before? No, that's the wrong one. Anybody ever hear that song before? Well, I can walk away. That's right, I might. No one in this room's ever heard that song before. We don't have enough old people here. That's the problem. That was a song from the 1950s for basically open source projects, sort of adopting the name Llama. Llama comes from Meta, developed Llama 4. They, sort of an open AI model. and you'll see lots of projects that are using the name Llama. So about a year ago now, a guy named Eric Curtin came to me, and he had tried to open up some pull requests with Ollama. Ollama is probably the most popular command line tool for running AI models locally on your laptops. And he had tried to open up a bunch of pull requests for them, and they basically ignored them or rejected all pull requests. And he went on and looked at a lot of stuff, and they basically were just rejecting. So they're a quote open tool, except they don't accept community contributions. So they're not really an open source. And they've started to do some stuff that is, in my opinion, is anti-open source. So Eric investigated what Ollama was doing, and they were using a very open project called Llama CPP. We'll be talking about that during the presentation. And Llama CPP actually does all the heavy lifting of making the AI model actually work on the systems. So Eric quickly wrote a bunch of bash scripts to basically fire up Llama CPP, pull down models, curl down models from different websites and things. He built a bash script, and Eric worked. I used to work for Rivos, the Red Hat in-vehicle operating system, basically edge computing. And Eric also worked in that group, so that's how I knew Eric. And he came to me and showed me the bash scripts. I was moving into Red Hat AI at the time. And I said, that's really cool. I said, but we may open up a project on this. It can't be written in Bash. So I said, we have to write it in Python, just so that it's easy for contributors to come in and contribute. And he was calling it Podman LLM at the time. And I said, well, first of all, we can't use the name Podman because the upstream Podman people hate it when people, abuse their name. And since I've been railing against the name Docker being used everywhere, I didn't want Podman to become a new adjective. So I said, well, everybody names things after Llama, and I knew the song Rama Llama Ding Dong, so we called it Rama Llama. That's the history, okay? So let's talk about, we're going to talk about Rama Llama, but we're going to be talking a lot about running AI models locally. The interesting thing here is that it's really, really easy to run an AI model on your local system, on your laptops. And I think that's critical, especially in open source development. And as, in the future, or very soon in the future, there's going to be lots and lots of reasons to running AI models locally. And we're going to cover a lot of that here, but as we get to edge devices and things like that. So there are a lot of tools out there right now for running AI locally on your system. And these are a few of them. VLLM is one that Red Hat's heavily invested in. There's Ollama is the one next to it. You see Rama Llama. We're going to be talking a little bit about Podman Desktop. Podman Desktop has a plugin called AI Lab Recipes, and that's why you see the Podman robot up there. So it's the CL as a robot. And then there's a bunch of web UI type projects that also run AI models locally. Where do you get AI model? Where do you get open AI model? Any AI model that you want to download. Hugging Face is probably the most popular place to get them right now. Almost everybody that builds an AI model, the first thing they do is get it into Hugging Face. Ollama also has a website where lots and lots of people get their AI models, and I think this is a big problem going forward, and I'll cover that during the presentation. The last thing we'll be talking a little bit about, one of the goals when you work with an AI model is actually to build an application that interacts with the AI model, right? How many people in this room are data scientists? 0, okay? I know nothing about AI. All right, at least I feel like the emperor with no clothes when I talk about AI. What I do know is about running software, and AI is just, in my opinion, is just another form of software. So as developers want to interact with AI, AI provides APIs, REST APIs that you can build. So if you want to build your own chatbot, say you have an AI model that's been trained on your data, you want to build a web interface that basically has, enter a human query here, and then that's the type of thing that developers are going to be developing. And we'll talk a little bit about that. So why is it important to run AI models locally? So I'm going to look first at the developer's point of view, and then we're going to look at your organizations, the companies that you work for, why they would care. So the first one is convenience for developers, convenience, right? I can just run the thing locally, right? You hear about AI models suddenly showing up, online, podcasts, whatever, right? The day that DeepSeek came out, actually Olama, where Ramalama was pulling DeepSeek from, and Olama were pulling it, the service melted because so many people wanted to go out and say, what is all this information about all of a sudden DeepSeek, it's all over the press, everybody wants to try it out. So just being able to run it locally, not have to go and pay someone to interact with the model or even go to a website, I just wanted to pull it down locally. The next one is ease of integration. So if I'm going to be building an app, it'd be really convenient to have the AI model running locally. So I can just build my app to integrate with it. I can figure out how I would use this AI model, and I can easily swap out AI models. Which one's better? Which one works better for my solution? And lastly, customization and control. These are all sort of, I can control that AI model. I can put wrappers around it. I can make sure that it doesn't do any bad. So from my point of view, again, I like to do things on my laptop, so it makes a lot of sense. For the organization's point of view, there's things like data privacy. Okay, so a lot of companies, you interact with an AI model and you ask it questions, and it knows nothing. You quickly figure out that it's stupid. It doesn't know anything about internal. You ask it a question about inside your company, and obviously it hasn't been trained on that data. Or if it has been trained on the data, you got a problem because your data is being leaked outside the company. But do you want to take your private information inside your company and upload it to a cloud AI? I don't think, most companies right now are very apprehensive about doing that. Then you have cost control. Anybody that's used a cloud AI for a serious business quickly figures out that you're going to get a huge bill at the end of the month. So AI online is very, very expensive. I was at the reason I missed this talk yesterday, I was at another conference yesterday, and I was on a panel where they were talking about AI and basically the costs. But the way I look at cost of AI tends to be, like buying a car versus leasing a car. You can get probably newer stuff quicker if you're leasing, but you're going to pay a lot more money for it. And I think the cost right now of using AI online is just prohibitively expensive. So just something to be warned about. And lastly is regulatory compliance. So there's lots of laws, there's lots of countries that don't want their data being used on computers that are outside of their country. There's, at least in the US, and I'm sure there's other countries, and I know Europe has lots of data controls. Things like in the US, there's a thing called HIPAA, which basically means my medical records can't go out to the cloud, so that they can't be shared. So there's lots and lots of regulatory rules about how your data, but you really need your data. In order to make these AIs useful, you've got to give them access to data. So there's a conundrum. But if you run everything in-house, then you don't have those issues. So Ramalama, we talked about where it comes from. Basically, it's a command line tool for running AI locally. The container, I didn't introduce myself, but hopefully a lot of you know who I am. I'm the guy that created Podman. Been working in container technologies, I say, long before Docker existed. So I have a hammer. AI looks like a nail. I want to stick it into a container. Okay, and there's lots and lots of reasons for that. But fundamentally, Ramalama is a wrapper around container engines for running AI models inside of containers and running it locally on your laptop. When DeepSeek happened back in February, I wrote an article talking about Ramalama at the time and the importance of running AI models inside of containers. From a security point of view, you were taking a massive unknown object, I like to think of it just as a big database, that is going to influence a piece of software that you may or may not trust, and that AI model is going to get to that software to do stuff on your system. You don't know what it's going to do. Matter of fact, Data scientists don't know what it's going to do. And it could influence the software to go out and do random things on your disk. So why not stick that in a container, shut down its network, and just give it the data you wanted to interact with? You don't want it interacting with your SSH keys in your home directory. You don't want to run it as root on your system. So there's lots and lots of, everybody's running into AI. It's like, oh, this is cool. I'm bringing in this engine that no one knows what it's going to do and running on my system. Don't let me get into MCPs, which is basically saying, I'm going to give this AI that I have no idea what it's going to do access to not only everything on my system, but everything in the world. And we've had movies about that. So Ramalama fundamentally is built on container engines, uses containers. It works with both Docker and Podman. What I will hesitate, we actually opened up discussions back in the fall with Docker to try to get them to participate in the Ramalama. And we met with them 2 or 3 times. I'm not their favorite person, but actually most of the guys that I went against Docker in the beginning have left Docker at this point. So they worked with us fairly well, but of course they went their own way, and Docker introduced something, I think around the beginning of the year, to run AI models locally. Funny thing is, Docker is not running their models inside of containers, and they're doing that for performance, and I'll talk a little bit about that later. But Podman is a lot more than just Docker. Like we used to say, if you want to move from Docker to Podman, you do alias Docker equals Podman. But Podman has added lots and lots of features. So more of the advanced features of Ramalama now require things like pods and different functionality that only Podman is. So you can do the basic functionality with Docker, but if you want to get into the advanced functionality of Ramalama, you need to use Podman. Ramalama also will run without containers altogether. And some people do that on Macs right now because you can get a little bit better performance. So when you run Ramalama, the first thing it does is it analyzes your system and says, what kind of GPU do you have access to on your system? Is it a CUDA? Is it a Mac? Is it a AMD system? And then goes out, and the weird thing about the AI world is all the software has to be custom compiled for your GPU. It doesn't really work well in a distribution mode in that the software cannot adjust itself. It has to be recompiled for each individual GPU. So in the container world, what we did is we created one that's compiled for CUDA, one that's compiled for Intel GPUs, one that's compiled for Mac GPUs, and for CPU. Okay, and what I'm going to be demonstrating today is a CPU. So a lot of you people sitting out there saying, my Mac doesn't have a GPU that can be used. You can use it with CPU. It looks a little like a ticker tape going across, but it actually works well enough if you're just developing AI, developing software to interact with the AI. It works well enough that it's not horrendous. So you can start to play with it. So when Ramalama discovers which GPU you have on it, it goes out to a container registry, quay.io/Ramalama, and pulls one of these images down to your system with all the software precompiled for that specific GPU. Then it goes out and pulls down a image, a model to run the system, and then finally launches a container with the model mounted into the container to run it locally. One of the things I really I've been fighting for with this tooling is that we need to make sure that AI models, AI content, all works as container images. I don't believe customers are going to have Hugging Face or Olama inside of their private networks. Customers, most users in large enterprises right now have bought into OCI, which container registries. So I believe models have to be stored in container registries. The people are going to want to control which models you're going to run inside of your company. If, for Red Hat's point of view, if Red Hat goes in and sells some of our solutions to it, and we have to come in with Olama or Hugging Face to install their enterprise version of their web services that store AI models, that's a big hindrance to sales. If you go in and say, oh, you already have Artifactory, you already have Docker Hub, you already have one of the 8,000 different types of OCI content, we want to be able to store it. So one of the things Rama Llama can do is convert models from Hugging Face or Olama into OCI content. So we want to be able to push that and then be able to use that. That also makes it available for Kubernetes. So when you want to run an AI model inside of Kubernetes, right now most people are just using S3 files. Well, if Kubernetes doesn't know, is anybody in the system using that S3 file? Or they're pulling from, a lot of people come up and say, I'm going to put Olama inside of a container and then run a Kubernetes. So you fire up Olama, it's going out and randomly pulling down a model from somewhere on the internet. And again, Kubernetes doesn't know about it. If I have 2 containers pulling down the same model, can I share it? No. So there's lots and lots of issues around running it. I like to tell people Rama Llama should never run in production. It's a developer tool. It develops containers to be able to run in production that use the AI models. So we talked about GPU acceleration in the previous slide, but this just shows you some of the different platforms. Macs are tremendous, and I'm the anti-Mac guy here. Macs have tremendous GPUs on them now to run it locally. So if you have an M4 Mac running with Podman Machine, it really is a nice experience. And at DevConf next week, Eric Curran, the guy that kicked off this project, will be bringing his Mac. I'm not allowed to touch a Mac contractually. Anyways, AMD has some really nice GPUs, NVIDIA, Intel, Vulkan. These tools run on top of Windows, but fundamentally containers mean Linux. Okay, so we're running VMs on top of Windows, on Macs to do it. Macs can actually run the AI models locally with --no container if you want, and then obviously on top of Linux you can run this as well, and CPUs are always also supported. So one of the interesting things, has anybody ever gone out to Hugging Face and looked for a model? Yeah, and what did you find? Yeah, you find 20, if you look for DeepSeek or you look for Granite or you look for anything, you're going to find 20 to 50 different models of it. Yeah, and so the problem is, just like if you go back to when Docker first started, Docker came up with a great concept, which is I call short names. And basically, if you said in Docker I want to run Nginx, you just say Docker run Nginx. You didn't go out to Docker Hub and do a search for Nginx. You just ran it. So with Olama stole the idea of short names from them, and when Olama came out, they just did Olama run DeepSeek, or Olama run whatever, Granite. So Rama Llama built on that, and what Rama Llama has is the concept of short names. Guess what it is? It's a file, name value pairs. You say DeepSeek, we think you want this one. You can specify the full URLs to pull down. You can specify anything else. You can customize short names to do it. It's a simple, name value pair for that. We also fall back when you're pulling from Olama. But the cool thing here is now we have open source community coming in, and people open up pull requests to shortnames.conf inside of Rama Llama and say, hey, Gemma 3 just came out. Why don't you pull down this model? And again, for normal humans, non-data scientists who don't know what the difference in quantization and all those different, 70B, 30B, 50B, so that's the goal. I would like to see eventually Rama Llama grow smarts about, we know the GPU, we know the amount of memory you have in it. It'd be really nice for short names to say, instead of pulling down that DeepSeek, you have a lot more memory, so I can pull down the bigger DeepSeek, and start to do that type of thing. But I need people smarter than me to come in and give me a database that says, for this amount of memory and this amount of this, you probably pull down a quantized version of this with 4-bit. I don't know. I don't even understand what they're talking about when they talk about it, and I'm too old to learn. So anyways, that's the concept of short names. And I don't know what this performance made easily. Let's just say, I'll skip that right now. So we talked earlier about running everything in a container. So basically you inject into the container the model. The models should not be installed inside of containers. So you don't want to tie the model to the source code that runs the model. They should be volume mounted in. Another thing, I'm standing on my high horse. Models are nothing like just databases. You wouldn't install a database with PostgreSQL in the same container, right? You would keep them separate. I believe the same thing about models. We're going to be talking about RAG data and data that you want the model to be able to interpret. So again, you'd stick that in the model and keep everything else on your host system isolated from the model. Or imagine in a Kubernetes world where you have hundreds of these processes running and stuff like that. You definitely want your models containerized so they can't interact with the rest of the system. Ramalama, out of the box, was built to be open source, right? We want to be open. So we basically say, wherever your model is stored, we will pull it from it. So Ramalama will pull from Olama, pull from Hugging Face, it'll pull from OCI, it'll pull from HTTP, website, files on disk. We will pull from anywhere to the system. Right now, we only push to OCI. Okay, again, we want people to think about getting it out of wherever they're stored locally, the ones you want to use, and then putting it into OCI when you want to push it. We also support any inference engines. Okay, if you think about the way Docker and Podman are created, I call them container engines, and there's a container runtime, run C, C run, libk run, kata. There's lots and lots of different runtimes. So in the container world, the engine's the thing that pulls down the software you're going to run, and then you can switch out the runtimes underneath. So in Ramalama, in the AI world, the runtimes are things called like Llama CPP, which is probably the most popular for low-end devices, VLLM, which is the most popular for high-end devices. Okay? Isn't it great when AI is listening to you and breaks in? I don't know how that, I don't even know why that does that. Okay. Google, off. This was not planned.
This suggests a component responsible for application lifecycle management. It would handle tasks like discovery, finding a... Hi, I'm Jim. We're about to go live. You can explore
Gemini, shut up. See, this was when you let the AIs out of containers. So anyways, so the basic idea is that Ramalama, you can swap out the runtimes. So there's Llama CPP, which is probably the primary one, that's the default one that we use. Whisper CPP is a recompiled version of Llama CPP that does things like voice to songs to text. I don't know, I listen to a song, I have no idea what they're saying. You can actually pipe through the song and it'll print out the actual, what's the word for? Lyrics, that's the word. So the bottom line is going forward, I think we also support OpenVINO. Lots and lots of people are coming to us and saying, we have different container engines. And the interesting thing is because we're going to use container images, if you want to build a container image for your specific runtime, then we can just take one of our existing images, add your software to it, build your own, and do it. We're also fully open. Again, we have lots and lots of people coming to us, pull requests. Sometimes I think we're more popular with contributors than we are with actual users. Which so our contributors, we've been around for basically since, let's say, September, and we're approaching 100 contributors. Because everybody that's contributing has their own special project, their own special GPUs, their own special tools, or their own special runtimes. Fundamentally, Ramalama has two commands, Ramalama run, which gets you a chatbot interaction with the service, and then we have Ramalama serve. So when you run Ramalama serve, the default in the AI world right now is to run a REST API based on OpenAI. Okay, so all the tools, VLLM, Llama CPP, everything I showed in the previous thing are always providing a REST API that's based on OpenAI. So the bottom line is if you build software that can interact with OpenAI, same software will be able to interact with it locally. So Ramalama serve will by default, it will always provide an OpenAI REST API. We just got in this last week, although it's broken. By the way, we release every Monday. So this thing is moving as fast as humanly possible. New images, everything. We just merged in a thing called Llama Stack. I'm going to cover that a little bit later, but Llama Stack is developed by Meta. IBM and Red Hat are both contributing heavily to Llama Stack. And what Llama Stack does is it builds a pipeline to get the AI to communicate. So most people interact with Llama CPP or VLLM, and that's running the model. But now you want to connect RAG databases, your own data to it. That's a different service, so you need to wire those together. When these things called MCPs, which is different services running on computers, you need to wire that together. Llama Stack is the tool right now that we're buying into, is the tool for connecting all these different services together. Just basically, Llama Stack provides something that the AI, a way for the human to interact, ask the AI a question, and tell the AI that it can get some data over here, or it can interact with this service over here. Again, I talked earlier about Ramalama not being used in production. Ramalama is a tool for using these containers, pulling these models, and wiring it all together. What Ramalama also does is it generates either Kubernetes YAML for running your application in production with the AI model and all the software, or generates a quadlet. Everybody here know what a quadlet is? Okay, about 50%, maybe more. Quadlets is the way Podman runs containers underneath systemd. So quadlets look like a systemd unit file that you can run basically containerized services underneath it. There's also in the Kubernetes world now, there's a thing called Kserve. So we're experimenting with that, but Kserve right now is not, in my opinion, is not really ready for, it's built on older versions of AI, not necessarily LLMs, and it's kind of tied to VLLM at this point. So I'd like to, I go back and forth with the Kserve people, but basically the idea is that we will look at what you're running and we will generate you a template that you can then customize to run stuff in production. Building your own AI. So again, the goal here, since most of you guys aren't data scientists, or nobody in here is a data scientist, not necessarily, you're not going to be building AI models necessarily, but what you are going to build is applications that need to interact with AI models. So you might want to customize and build code. So Podman Desktop has a thing called AI Lab Recipes. And these are different tools and different example programs. And I think they have them in Python, they have them in JavaScript and a few other languages. And again, it's contributions. And this is how you build a chatbot that interacts with an AI model. This is how you develop a tool to take PDFs and have them go through. Or this is how you take a document and upload it and have a summarizer. So they have lots and lots of examples. So there's a longer version of this talk that I'm not going to do that talks about Podman Desktop and shows all those. Podman Desktop and Podman Desktop's AI Lab Recipes and Ramalama are slowly merging together. Okay, or Ramalama is becoming the functional underneath of what Podman Desktop AI Lab Recipes is. So we have an AI engine. We have the ability to pull the model. What about your data? Again, when you interact with an AI, if you ask it about something that's internal to your company or private to you, it doesn't know, it gives you bad answers. So in the AI world, the way this is handled now is called retrieval augmented generation, okay? And I always have to read that because I can never remember what the hell, but everybody in the AI world calls it RAG. So what RAG is basically taking your PDFs, taking your documents, compiling it up into a format that AI can interact with. It basically builds JSON and then recompiles it into the same types of matrix mathematics that has worked. So basically you're going to take your documents and somehow get it into it. So Ramalama has a command called Ramalama RAG. And what Ramalama RAG will do is take your documents, PDFs, and markdown languages, HTTP pages, text files, and will recompile it into it. It's taking advantage of an awesome tool from IBM called Dockling. So Dockling is running inside of a container and actually will take and look at your PDFs. I think it says docx, so Windows documents, PPE, just about anything, and then they convert it into some kind of format that can be interpreted by the AI. So what Ramalama RAG does is takes those documents and outputs an OCI image. Eventually, these will be OCI artifacts. Then you can simply use Ramalama-RAG, serve-RAG, and it'll pull down your AI data, I mean your compiled RAG data, and hook it up with the model. So in this case, we're basically saying, take local PDF, take a markdown file from a website, compile it through docling, output it in OCI registry. I can push that to an OCI registry, and now I can pull, Ramalama will pull it from the OCI registry, run it locally. And again, when we generate quadlets of Kubernetes YAML, we basically encode that into Kubernetes YAML on how it would interact. So you can imagine that you could use tooling like this to build a online chain where you're constantly updating it with new information about going on inside of your company, push it to your private registry, and then have lots and lots of services running and automatically pulling it down. The interesting thing, by using OCI for storing models and using it for storing RAG data, it basically allows you to do things like scanning. BOMs, bills of materials. Allows you to version it. Okay, so I can have my RAG database constantly updated. I might want to lock in at a specific version, right? So all these type of tooling, if you don't do that, you're basically putting this stuff in files somewhere and trying to handle it. But if we just concentrate on doing everything in OCI, we can get to take advantage of everything that OCI provides. So agentic, I always want to put up the Arnold Terminator. So this is Skynet. And this is probably the most popular thing in AI world right now. It's called, you'll hear things like agentic or agents. The protocol is called MCP, Model Context Protocol. So they've defined a protocol for that you can hand to an AI. You can say you could say something like, list all of the pods I have running inside my cluster. And OpenShift and Kubernetes right now are building MCP servers. So the AI will figure that out. We'll talk to the REST API provided by an MCP server, actually use your credentials to talk to something like OpenShift and basically get back that type of thing. You don't have to do K-list. All this stuff that you're seeing about developers using AI to build code and interact, take a look at my code, things like that, that's all MCP. So this is basically taking something that no one understands, handing it to and then allowing it to interact with the file system, or allowing it to interact with websites, or allowing it to, so that's what MCP is all about. There's a guy named Michael Clifford who is he's a real AI engineer working for Red Hat. He actually understands what things like quantization and things like that mean. And I talked to him back in January, and I said he was working on agentic in MCP. And he said, oh, this is all crap. He said, it's just really bad. And I saw him about 3 weeks ago at Red Hat Summit, and I said, you said this was all bad, now it's everywhere. And he said, it's been unbelievable how much has improved in 4 months. So it's just, this stuff is coming so fast that, frankly, it's a little bit scary. It's incredibly impressive, but who knows? So we talked a little bit about Llama Stack. So this is, by the way, Ramalama's logo. It's a llama dressed up like Fonzie, a very American thing, but Fonzie was from the 1950s, based on the song. So that's where think of a 1950s tough guy motorcyclist. And Podman Desktop with AI Lab Recipes, they both are moving towards Llama Stack. I'm still not sure if that's really what Llama Stack's logo is, but it's so cute. Llama sitting on a stack of pancakes. Llama Stack's going to be integrated into Podman AI Lab Recipes. And I said it just went in this past week, and it's totally broken. But eventually, when you run Ramalama Serve, we will launch a Llama. Right now, you can do a --API Llama Stack, and it will launch basically 2 containers. It will launch a pod. One container is running Llama Stack, one's running the engine, and then we wire it all together. The next step is to add RAG database, wire that together. Then you're going to add MCPs. So we will build you a whole set of containers that basically have, you'll talk to Llama Stack and Llama Stack will reroute your data to all the different services that you're going to be plugging into it. And so Llama Stack basically helps you build applications fast. This is sort of their sales pitch. But bottom line, just think about how would you wire together something that's serving a RAG database, something that's serving an MCP, and something that's serving a data. And that's really what Llama Stack's all about. If you come to DevConf next week, we will be showing a thing called multimodal. You will hear the terms multi-model and multimodal. Multimodal means using one model with multiple different ways of interacting with it. So I talked about sound to text. We have a demo that I won't be showing, mainly because I don't have it set up, and it really works well on a Mac, that takes video stream and hands it to an AI. So it'll take a video stream, and then you can ask questions to the video stream. So it's basically interpreting the video stream and interpreting the questions. So that means you're interacting with the AI model in two different ways, multimodal, interacting it. And it works incredibly well. And if you get to see the demo at some point, it's, we did it at Red Hat Summit, and it was really, really cool. The problem, we were asking the AI model what it sees. And I walked in front of it one time, and it said, I see an elderly man walking in front of it. So I'm demanding that they fix the sensitivity level to not call me an elderly gentleman. We also, you could have gone in, the other question we were asking is what superstar or whatever, what star does this person look like? What celebrity does this person look like? And it got stuck on like Tom Hanks, Justin Bieber, and women were walking in front of it. And I think depending on your skin color, they would say Vanessa Williams and these. But it was it's really interesting. And this was running locally on a Mac with a very small model, and it did an incredible good job of doing it. So you can imagine this getting better and better. And really, what you want to do with multimodal is things like, it'd be really nice to have a camera that's watching the street and tells you if the FedEx guy is walking up to the door with a package, or if a guy with a gun is walking up to the house, right? So you probably want to interact with those two pieces of information differently. Multimodal also, again, thinking about this video stream, it makes you realize that you really want some edge deployments of AI. You would not want to have 10,000 video streams coming back to a centralized core system for the AI to interpret and then the message get back, right? That video stream has to be interpreted locally. So, I believe that edge deployments of AI are going to become more and more critical. Eventually, we're going to drive up to a McDonald's in any language in the world and say, give me the 2 cheeseburgers and the fries. And the human's not going to be interpreting what I've said. It's going to be an AI model. So those AI models, again, are not going to be running in central headquarters. They're going to be running inside of the McDonald's. So running AI models locally and fully functional for specific tasks is going to be a huge thing in the future. Anybody want to see a demo? Okay. So is this? So Ramalama version. We just released this past week. This is a live demo, so everybody don't use the internet because they're going to be pulling models. And it looks good up there. Okay. So Ramalama version, we just released 0.9. We're releasing on a weekly basis. It's not a 1.0 product, that's for sure. But it's usable now for people playing around and developing software. But there are some instability issues once in a while. So I'm running it locally, Ramalama info. This is mainly something we ask you for when you report an issue. We'll ask you for Ramalama info. And this does things like what container engine you're running. So I'm running Podman underneath the covers, and it just takes the Podman info, combines it with Ramalama info or Docker info, and combines it all up. So it gives us some information. But you could also look at what it's interpreting. This will actually show you what GPUs you're using, what Ramalama is seeing as the GPUs that you're losing on your system. So there's just a decent amount of information here that you can interpret. So what I'm going to do right now is, this is a small model. Now, small model, when I say a small model, it's only 135 megabytes. But models can get really, really huge. And so this is actually pulling down. So I'm doing Ramalama pull. If I did a Ramalama run, it does a Ramalama pull behind the scenes. And so I removed the model, and now it's pulling it down, and it pulled it down because we have a decent internet here in a few seconds. But if you're pulling, a Llama CPP 70 gigabytes, it's going to take a while. So now I'm going to show you in the local storage. Okay, so it just basically shows that it pulled down the model, and it tells you that it was pulled from a Llama. And if you pulled it from Hugging Face, it would show where it was pulled for. So, and if you pulled it from OCI, it would also show that. And these are all the images that are currently built. My machine is where we're currently building these. We want to get this automated at some point. And we're going to work with Conflux to get all these different images. But these are all the different images that have been pulled down. But basically, it's just doing a Podman images to show you the images that are on the system. Let me shrink this a little bit. Is that better? Yeah, you can still see it. So here you can see Ramalama has a command called dry run. And what dry run does is basically say, don't do the operation, but show me the command that you're going to execute to run the command. So you can see here that we're using Podman for the engine to do our containers. Now I'm going to do a different dry run, and this just blew up. So it should have showed you that I was using Ramalama. I don't know why that didn't work. Oh, that's a bug. I don't have the latest code. So we don't use the latest image. We use 090. So that should have showed you. But believe it or not, it's there. And again, when we run containers, I'm just showing you different parts of the Ramalama command to get you focused on it. Here you can see that from a security point of view, we're turning off all privileges. So we'll make sure that the container is locked down as tightly as possible. And then the last one I'm going to show you is when you do a Ramalama run command, we're shutting the network off. So from the container's point of view, even if it wasn't able to attack your system, it would basically not be able to communicate back to some other site to tell it about. We also have a kind of a queue thing. So if you're running Podman, it'll show a little, the prompt that I'm about to show, you'll see the little tiny sail. And if you're running with Docker, it'll show a whale. I think that's cool. So here I'm actually running a model, and this model is actually running Granite, which is a fairly large model on the system. And basically it comes up with a prompt, just like you see at ChatGPT. I'm actually running this thing with just CPU, okay? I have NVIDIA GPU inside of my laptop, and they haven't updated. NVIDIA has not updated this off of Fedora 42, so my GPU has not worked properly since Fedora 41. So this is going to show you, if you don't have GPUs, how fast it is. Sorry about so it's, this is a fairly powerful laptop, but as you can see, it's not horrendous asking you questions about that. So anyways, that's a AI running locally. So this is going to take that model that I downloaded and convert it into an OCI. So basically, what it's doing behind the covers, it's doing a Podman build. So it takes the model, sticks it into a format, and then allows you, now you can take that small LM and push it up to a container registry, and then Ramalama can use it from that point forward. So now you've taken that model from a public registry and potentially stored it on a private registry. And here we are showing it, it's existing Podman images at this point. So now I'm going to take a model, and instead of serving it directly, I want to generate a Kubernetes. So basically I've taken the model I just created, and I'm telling it to generate a Kubernetes YAML file for running that in production. And you'd see here basically a Kubernetes YAML file that basically uses it, and you will not see Llama Llama command being used inside of this. You'll see here Llama server, which is a wrapper around Llama CPP. So that's running Llama server inside of a container. But basically in production, you would run this container with Llama CPP inside of it or VLLM inside of it and run that inside your Kubernetes cluster. You wouldn't use it. You'd also, because the model's stored in OCI, Kubernetes knows how to pull OCI images. It knows how to maintain OCI images. So let's quit. Similarly here, we're going to generate quadlets. And in quadlets, you know, quadlets tend to be multiple files. So we're going to show that we're going to pull down an image. This is a volume file for the images. Here's the image that we'll pull down for running it on the system. Here is a quadlet. So this is the actual quadlet that uses it. It takes, you know, DRIs, mounts them into it, tells what image. Again, sorry about the video jumping, but you can see that that image is a Llama Llama image. So the default image that everybody pulls, if you don't have a GPU, is to pull Llama Llama. If this GPU on my machine was working, we would have pulled the CUDA image, you know, with the NVIDIA GPU. We'll do quick editing here. Sorry about not being prepared for this. Didn't I just fix that? Yep. Okay, so this is the serve part of it. Actually, so now I've actually served a model, so I'm actually showing it serving a model, and the tool will actually show you what the REST API, the endpoint to connect to. You can switch around the ports and all that stuff. Underneath the covers now, you'll see that is running a container on the system. When I do a Llama Llama run, it actually does the serve in the background and then wires it up together. So you can see that that launched a container on the system, and then similarly, you can see it is a container inside of Podman PS. And now I'm going to run Firefox, and hopefully this part will work. And now you can see, so this is just a web interface that's built into Llama CPP that you can actually do a chatbot directly with. So who is Dan Walsh? And I'm always happy that it knows who I am. And so this is basically doing the same thing with the Granite model. And it's going to come out in Dan Walsh, and we'll see what it interprets that as. Dan Walsh is a renowned figure in the field of cybersecurity. Ooh, boy, I'm pretty good. I'm a director of strategy. I didn't get that, just got that promotion, and a CTO. He's recognized significant contributor to open source SE Linux. That's correct. Joined in 2010. I joined in 2001. They worked for IBM. I've never worked for IBM in my life.
You'll never lose this.
So, yeah. So, yeah. I include pretty prestigious NSA stuff. I don't know. Anyways, so you can see that AI knows a little bit about me, but hallucinates a little bit. So what's really good is I could take RAG database, and when I played with the RAG database before, I've taken my book and asked it. My book's dedicated to my mother, and you could ask questions like, "Who is the book dedicated?" in the RAG. That's the really cool stuff, but I don't have that part of the demo right now. Anyways, so I'm going to stop the model from running. Now I'm going to run it with a Llama stack, and you can see that now we have two API endpoints. So it's using, when you run with Llama Stack, you can talk directly to the Llama Stack API. To talk directly to the OpenAI, basically what we just did, you would have to change it to use V1. You also notice that I'm actually running a pod behind the covers because I have Llama Stack running in one container. I have Llama CPP server running in a different container. And this next command hopefully works, because it was broken yesterday. Yeah, it seemed to kill it. And now the containers are exiting. So that, I already did this part. I think, I don't know if there's anything else to show. But at this point, I think I'm running out of time anyways. We already did this. Thank you. So at this point, we go back to the slides. And now, at this point, we do questions. And we have a lot of AI-generated versions of basically Ramalama talking to Podman, and actually even demonstrates my book. But anyways, these are all the links. Anybody want to take a photograph of where you can get more information about all the different projects going on, and any questions?
You mentioned Intel as a vendor that supports hardware acceleration. Does that include Intel Alchemist and Battlemage DGPUs? Because
see, this is when you realize I have no clothes on right now.
Right.
So I don't know. Again, that's something we allow open source people to come in and add. So there's a lot of people are using Intel hardware, sometimes ancient Intel hardware. So my best advice to you would be to try it out. Okay, but it supports, it probably supports anything. Anybody who has that piece of hardware has opened up a contribution to the upstream. Yeah.
It's all one API. It's such a pain otherwise, like set it up manually. I mean, with iPads, yeah, but it's all one API. So.
You said that the model should not be in the same container as the AI. Are any recommendations regarding the AI collaboration with IBM, how to use it on Fedora or other Linux distributions? Because the new AI accelerator and the new C hardware requires AI software?
Yeah, well, first of all, we're working closely with IBM. They help pay my paycheck. So IBM right now is working on Z-Series. They're contributing Z-Series support. They're contributing PowerPC support. Z system. Well, yeah, basically we want IBM to build container files specific for Z-Series and specific for them, but they have to contribute to Llama CPP to get Llama CPP to be able to interact with their GPUs. And again, we're open to anybody. Some of the largest contributors to Ramalama right now are actually Chinese companies. So China is, because China is being sort of cut out from CUDA and NVIDIA, they're off developing their own. So we have a thing called Musa and another thing called Khan, which are container images contributed by Chinese companies. And so what we're seeing is exactly that. Is like, we want to play in this game of contributing open source. And again, because of the power of open source, There are basically two guys at Red Hat right now who are working on Ramalama project, but we have now a lot of Red Hat contributors, but we have a lot of external contributors, and I think it's approaching 90 different contributors in 9 months to the project. The project right now has about 1,700 stars. So that's a rating. So I'd like everybody to go on to Ramalama and give it a star and say a like or whatever the hell this thing is, just because those numbers are important, and to continue to get Red Hat to continue to support building this project. Anybody else got questions?
The output generated by Ramalama for Kubernetes, is that just running a single instance of the model in Kubernetes, or does it actually support distributed inference?
So it builds a deployment with a replica of one, and you're going to quickly know I really don't know what I'm talking about in Kubernetes world either. But so the main idea is here's the containers, here's the Kubernetes YAML that you understand with the deployment, and if you wanted to run it on two, now fundamentally it's going to match what you're running locally. But if you're running on a Mac, it's going to say use the Ramalama pack. Well, if you want to run in CUDA, you'd have to go and change the container image to say CUDA instead of Ramalama, and then the tools will be smart enough to handle that. And then it becomes your responsibility when you go to deployment to make sure that the machines that you're running it on actually have support for the GPU that you're running on. So we're not trying to handle that, but again, it's just like here's containers, here's how you mount an OCI image into the container, here's how all that stuff is being taken care of by people like me who understand how to do this. Yeah.
Probably have time just for one more last question.
I'm interested into actually playing with the models, and then a few slides back you showed that you could just get a PDF file and then feed it to some sort of a registry. And then I missed the part, there was in the middle there was a MD file from some random server. What was that about? I get it, like you can get a PDF and feed it to the registry, but then...
So that's Ramalama RAG. So Ramalama RAG will take your documents and compile it into a format. Actually, right now we're using a thing called Quadrant underneath the covers. So there's Milvis, you might have heard of. There's different ways that you can compile data into a AI database. And there's all these companies generating, and two of them are Quadrant and Milvis. I think Llama Stack has their own. And right now we have it hard-coded to output a Quadrant database inside of OCI. What we want to do is allow you to specify, I don't want Quadrant, I want Milvis. Again, because a lot of this stuff's evolving. It's not, we want to allow you to pick which kind of database you want to interact with. And data scientists would tell you for this type of thing, Milvis works better. For this type of thing, I don't understand what the differences are, but that's not AI models, that's AI data. So you're basically taking your data, compiling it into a format that now you could query. Like when I asked about Dan Walsh, I could have put my resume in there, and it would have used my resume as the primary source rather than just random crap that it downloaded off the internet about who I am. Right. Right. And you continue to evolve it. Whether or not, again, you might want to look at what we're doing inside of that container, because I'm not sure this is going to scale to. Everybody's going to go in and do it. Oh, that's really cool. Now let me give it 10,000 documents. I'm not sure our tooling is going to do it, but it's simple Python code that we're calling into Docklink to do it. Yes. I thought I had a full hour.
Yeah, but I need to propose the laptop.
Okay. All right. So anyways, thanks for coming, and I'll be around for, I'm also giving a container buff tomorrow if you want to come in and talk about containers, and we can do some other stuff. So anyways, thanks for coming.
I think we're almost ready to go. I'm excited the video actually just worked. I've never used this ARM laptop on a projector before. Yeah, so, I mean, following on from Dan and stuck between Dan and lunch, I will try and get this done as quick as possible. I haven't practiced this at all. I was asked to literally do this last night to fill in. Let's go. I'll give myself an intro. Peter Robinson. I've worked in the Fedora ecosystem forever. I was directly involved in various ARM bootstraps. So I was involved in ARM v5 and then ARM v7 hard float and then ARM 64. I maintain the Raspberry Pi support in Fedora and a whole lot of other ARM stuff. As always, it's a fast-moving ecosystem. So I thought we'll just give a quick update because I'm always getting questions about various other bits and pieces. I worked at Red Hat for 12 years. I've recently moved to ARM themselves, not working on anything to do with Fedora at ARM, but sort of still actively involved in driving a whole lot of the open source ecosystem behind the scenes. So, support for various devices in Fedora. Raspberry Pi. It's the one that everyone knows and loves. It's widely available. Pi 3, mostly done. Pi 4, also mostly done. Some interesting sort of peripherals are starting to land upstream. So things like hardware, video encode, decode, camera support, various other bits and pieces. The Raspberry Pi 5, it works in Fedora 42. It's not useful in Fedora 42. So we boot, we've got serial console, we've got micro SD storage, and general compute. It's a device that if you want to hack on the hardware and the kernel and stuff like that, you can start to do that on Fedora. We're getting PCI support soon. The big blocker to make it useful is the Pi Foundation has decided, and if you read tea leaves and various other bits and pieces, you can probably work that, I mean, they've been from the Pi 1 all the way through to the Pi 5, they've been using Broadcom as the hardware, like the SoC vendor. With the Pi 5, they've split a whole lot of stuff out into a auxiliary chip, like they refer to it as a Southbridge chip if you look at a traditional sort of x86 motherboard, where a lot of their USB, network, audio, etc., hang off this RP1 chip. So a lot of the things that sort of just work from the Pi 2 to the Pi 3 to the Pi 4 are no longer there on the Pi 5 because they're using their own stuff, and they have this weird chip called the RP1 that contains all of this IP, and we're waiting for that support to land upstream. And most of the IP on that is like standard IP that's used across the ecosystem. So once that sort of root device is there, a whole lot of things should just light up and work. The problem is waiting for it to get upstream. There are patches out there. It's moving forward nowhere near as fast as I or the community would like, but we're getting there. We have PCI working now for 43. If the RP1 stuff lands in 6.17, I will probably beg the Fedora kernel maintainer to pull that back. So we're almost there. One of the things that GNOME and a bunch of the desktops started doing is auto-suspend, and that's a big problem. Someone in the community started working on auto-suspend, got it mostly there for Pi 3, and decided it was way too hard and walked away. So yeah, but we're getting there. The Pi Foundation is getting better. Like, they're the ones that are driving the
video encodes, decode stuff upstream. They're leading a lot of the stuff in like the complex camera stacks and things like that. They are improving. They just have a lot of catch up to do. And like every other company, they're a small company with limited resources, so they have to focus stuff. We're getting there. It's not perfect, but, well, we are where we are. NVIDIA. So there are multiple Jetson generations. There's multiple devices coming out onto the market that vaguely look like Jetson devices, but are massive, big, like $3,000 workstation things. Like they had Project Digits, which is now I think called DGX Spark, things like that. Most of the IP in those devices actually look very similar to a Jetson. The Jetson Orin, which is the current generation of Jetson, is well supported. It's the first device where they support multi-purpose distributions, like multiple distributions rather than just their own. That was 6 or 7 years of my work with NVIDIA while I was at Red Hat to get that. The GPU driver is still out of tree, but the vast majority of the rest of the stuff just works on Fedora. You know, you can run up standard EDK2, UEFI, install it in the standard way, encryption, various other bits and pieces, and it generally just works. You then need to pull down the GPU drivers and like the AI drivers, but you know, that's no different to the rest of the NVIDIA ecosystem there. And the nice thing about Orin is they have a nano version, which is quite cheap and quite powerful, right up to the AGX version, which is a lot more expensive and powerful, but they all basically look the same. They're ARM 8.2 class of devices, so much more modern than a lot of the other ARM cores that are widely available. And, you know, they're a good, powerful device. Qualcomm. I think the Qualcomm stuff is very similar to the Raspberry Pi. There's a huge amount of interest in it because of the Windows on ARM laptops. The laptops are in a various state of support. The IoT SoCs are actually very well supported. Qualcomm is actively engaging in the system-ready stuff. Their teams are actively testing Fedora on these devices, and we're working with them to sort of get firmwares in place so they just work. Where with the laptops, there's a bunch of work happening behind the scenes to improve the firmware to be more Linux friendly. And like with all big companies, that just takes time. So hopefully soon they will improve. The device I have here that I'm presenting on is X13S. That was the first generation where they actively supported. We worked with Lenovo and Qualcomm to get the firmware enabled so that it just works. We're getting there on the newer generations, and we're hopefully getting to a point where before long Linux support should be just there. But you know, I know there's a bunch of people in Fedora that are using the newer generation Qualcomm laptops, and they work pretty well, but there's a lot of quirks involved. But when you get them up and running, they're nice, powerful devices. They typically just work. They need some more work around things like suspend, resume. This will do suspend to idle, but you sort of like not the deeper suspend modes. But I'll quite happily get 15 plus hours of battery life running Linux on this device. Rock chips. The older rock chips are really well supported. Like literally, I don't think there's any bit of IP in these devices we don't support now. Cameras, all sorts of stuff just work. The newer 3500 series mostly works, improving rapidly. GPU support is all there. There's bits of the firmware we can't distribute in Fedora. So in I think it was the 42 cycle, I started doing copper builds where we can deal with it there. So it's a bit more complex to deal with. I'm working to improve that in the 43 life cycle, and we're even starting to get things like NPU support and various other bits and pieces there. There's a whole bunch of really interesting devices here, like handheld gaming devices, e-paper tablets, various other bits and pieces where we're starting to get interest in the community. How do we support this? And it's like, ooh, you know, but like the base support is actually very good there. The GPU is a Mali GPU. It works really well out of the box. There's lots of optimization being done on that driver. And yeah, I think these devices are nice and cheap. The 3588 is pretty powerful. Another 8.2, 8.2 platform. And there's like newer platforms that are announced that aren't available yet, but you know. And then there's a whole raft of other stuff. So AMD Xilinx have these relatively powerful devices with honking great FPGAs on board. TI has some interesting stuff around their PRUs and their real-time stuff, used extensively in robotics and those sort of use cases. Working with a whole lot of those vendors as part of the System Ready program and a platform called OneLab. OneLab has Fedora as one of the key distros that they test all of the hardware against. So through that program at Linaro, we're getting TI, Xilinx, Renesas, and a whole lot of other hardware vendors that are just testing their devices on Fedora, filing tickets to get drivers enabled and things fixed, and everything just works. So there's a bunch of stuff there around like real-time code processors and FPGAs, where we're seeing users actually do a whole lot of fun and interesting stuff with robotics and a whole lot of things that I just wish I had the time and the money to play with. Next-gen platforms. The Radsa Orion 6 is the first of the ARMv9 platforms out in the market. It's relatively reasonably priced for, I think, a 12-core ARMv9 platform, up to 64 gig of RAM. I think 64 gigs about a $400 device. With the ACPI firmware, it just works with Fedora 42. That doesn't give you GPU and a whole lot of the fun stuff. So that's working with upstream. There's a whole lot of people in ARM internally that are interested in this because it's the first ARMv9 non-data center, non-phone sort of general purpose platform. So, I mean, I worked years ago with some of the ARM people to enable things like PAC BTI in Fedora, which is some really good security features that come with some of the ARM CPUs these days. And I think it's been there for like 5 years and we've never really been able to like widely test it because there's not that many sort of decent community devices out there. And pleasantly surprised that when we actually tested it on Fedora, it all just worked. Yay. There's also some, like earlier this year announced the Cortex A320, which is a low-end ARMv9 device. I'm hoping like hell that it's going to quickly supplant like the Cortex A53s that are ARM 8.0 and actually really long in the teeth these days. There's a whole lot of rumored and interesting devices coming down the pipe. I look forward to those sort of being out in the ecosystem. And yeah, so there's a bunch of interesting stuff there. And a lot of this stuff is with the OneLab and things like that actually being tested on Fedora. So I'm hoping like as these things come to light, with a lot of the, you know, standardized ARM IP out there now, that a lot of them should actually just work. So, you know, it's ultimately, yes, watch this space. Yeah, so a few other bits and pieces. Cloud and servers mostly just work. Lots of people in the ecosystem, Amazon, Microsoft, Google, in the cloud space, just working on optimizing their platforms for various different pieces. A lot of the boot firmware for the cheaper, lower-end devices that we're supporting in Fedora are now getting a lot of useful and interesting user space improvements like boot menus, secure boot, HTTP boot, various other bits and pieces. ARM is thankfully now engaging more and improving the Mali GPUs. The camera ecosystem is slowly improving. Like the Pi Foundation is very much leading that charge, which is nice. Qualcomm and NVIDIA less so, but things are getting better there. We're starting to see quite a community around some of the NPU stuff. The first devices are now supported in Mesa, and I'm working and looking at how we can integrate that with some of the AI workflows, so things like Llama CPP and a whole bunch of stuff I'm sure Dan went through on his talk. Things like Vulkan Compute are starting to get very interesting. I've been running and playing with Vulkan Compute on this laptop a bit, and Rustical as well. So there's they're not super powered devices like a honking great NVIDIA GPU, but it's just enough sort of AI where you can actually do with voice models and things like that some pretty cool stuff. I'm looking at how I can possibly use some of these ARM devices with NPUs and voice detection to do sort of Amazon Alexa style stuff on Fedora, so that I don't have to open my internal home to Amazon or Google or other clouds listening to me all the time. I'm leaving Apple to the Asahi people. I've said to a bunch of them at different times, if we can collaborate there, let me know. But generally they're doing very well. A bunch of work behind the scenes with the Qualcomm team and their open source team to improve things for the Windows on ARM devices running Linux. And so hopefully some of their internal firmware work and things like that, as I mentioned, gets out to devices soon. So that's most of the ARM device ecosystem support in Fedora. I was given very short notice for this presentation. I was asked sort of late yesterday afternoon if I could fill in a slot. So do we have any questions?
So can you explain a little bit about your plan for the proprietary firmwares? Are you going to bundle those with something like U-boot and move U-boot to Copper? Or are you going to have a separate firmware just there for in this Copper and U-boot still the same upstream for Fedora?
So the vast majority, at the moment, the Rockchips 3500 series devices are in the Copper. The proprietary bit in that is the memory training driver. But it includes, that is built as part of a firmware stack, which includes U-boot and other bits. So there's ARM-trusted firmware, U-boot, a firmware for the power management coprocessor, so the SCP, plus the memory training. So for the devices we can support directly in Fedora, that will remain in Fedora proper. For the devices like the Rockchips 3500 series, we need to do it for the TI devices. We need to do it for a couple of the others. Those ones alone will be built in Copper and separate because we can't ship them in Fedora proper, but they are the same U-boot builds and things like that. Initially, I'm going to be building the TI firmwares. It looks like TA may take a bunch of them over and just ship that as part of their device, at which point when that happens, I'm just going to drop them because we don't need to ship them. So it'll be SoC by SoC, and it may be that someone can rewrite the memory training as there's a bunch of memory training drivers in U-boot proper that are open. Like, so any of the devices pre 3500 series in Rockchip, so the 3399s and the 3328s, things like that, are actually all open drivers. So if we get in a situation, and so it's things like DDR5 for some reason is complicated and the drivers aren't open yet. And it may be they can be opened at some point, maybe there's reasons they can't be. And so at the moment, if it's fully open, it'll be in Fedora. If it's not, I'm going to do it in Copper, because at least that way we can support those. While it's less than ideal, we can at least support those devices so people get a relatively good user experience.
So we had a brief discussion on Wednesday about handhelds, and I told you that on the low end, I don't think there's a lot of interest to run Fedora on those, but on the high end, especially last year, there are 2 or 3 manufacturers that are coming out with these devices that run the Snapdragon 8 Gen 2 chips that high-end phones run. And for those, I think they also have a bit of a bigger screen. There might be an interest to run Fedora. So can you comment a bit on Snapdragon support itself? And
so the Snapdragon support was very much in the Qualcomm, so Windows on ARM stuff. Google is moving Android to a new firmware bootloader called, I think it's GUP or something like that. And that's actually a UEFI application that runs on a UEFI firmware. If they support that, we will be able to support Fedora actually quite well on those devices. There's a lot of work in like the ARM ecosystem. So like Linaro has a team called the Qualcomm Landing Team that like is a collaboration between Linaro and Qualcomm to support devices in Linux and Android and all sorts of things like that. So I'm not going to say for sure, but I am pretty certain we could support Fedora on those devices. And so, if there's, if we can have a conversation with those manufacturers, I would say it's likely possible, because a lot of the, the 8CX Gen 3, which I think is in this laptop, in Linux is really well supported. And so, if there's a handheld with that, it wouldn't be a lot of effort.
So, like many ARM devices are still, maybe for legacy reasons, basically booting from SD cards and not being actually like installed in the normal way. Do you think this ever going away, or is there always being this split, like, yeah, a laptop is just installed, but on these ARM devices I need to fiddle with SD cards and MMC and stuff like that?
It depends. So if you look at like the Jetson platforms, they have standard UEFI firmwares on standalone flash. You shove whatever storage you would like in them, NVMe or whatever, and you can install Fedora in the normal way. The lower end devices, I don't think it will go away, just simply because it's around cost. But there's like the Radsa devices, a large chunk of them already come with SPI firmware and work in the more traditional x86 way. And I've worked with a couple of the hardware manufacturers and said, this is why we'd like SPI Flash, where we can put the firmware on there, because it gives people a more easy to get started experience. And I think generally we're moving more in that direction as the devices become more capable. The hardware vendors are starting to see the value of spending, a few extra cents on the device to get that experience. And I'm talking with a couple of the vendors as well about how we can actually, with that SPI Flash, actually get them to do a high quality firmware that gets updates through Linux vendor firmware service. And so like that's something I'm working on. Some of those conversations are slow burner conversations that happen behind the scenes. At Lenaro Connect recently, there was a discussion around CRA, and one of those device manufacturers went, oh, this doesn't apply to us, to which one of the CRA specialists said, do you sell your devices in Europe? And they said, yes. Do they run software? And they said, yes. You are affected by this. And the response was almost tears. And so I think things like that, if a device vendor can say, we support this tiny little firmware, and this is how we update it through Linux Vendor Firmware Service, and by doing that, we can support Fedora and any distro that someone wants. That large chunk of software that is the Linux distro is the Linux distro's problem to deal with, and all we have to deal with is this tiny shimmer firmware. That makes it more interesting. It's cheaper for them to put that chip on there and do a Linux vendor firmware and make and partner with Linux distros for the rest of it. And so there's things like that which I think actually will quickly drive vendors to doing that because it gives them this nice abstraction. So it's an interesting law that's scaring the shit out of everyone. But I think from our point of view, it will end up being quite positive for that device support sort of thing. So yeah, there's a bunch of like slow burning discussions there where I wouldn't be surprised where I've had discussions with vendors and said like, this is how you do it. This is various reasons for it, and then suddenly devices start to appear working like that.
Still have time for one question? No question then?
Everyone wants lunch.
Probably. Thank you. Thank you, Peter.
Thank you.